আগে তুমি রেডি হয়ে গেছো তো? না না সেলের স্লাইড গুলো না না ভাগ্যিস আমি ভাবছি পরে করবো, ভাগ্যিস করে গেছি হুট করে শুরু করবো। 11 জন কজন বলবো, অতজনই ইয়ার কোশ্চেন করবে। মনসা আছে, মনসা কি মনসা? ওই যে একজন মনসা, ডিজাইন ইনোভাইন ওদের বন্ধু হবে তাহলে। নাহালা নাহালা মনসা মনিকা দেখছি ও একই নাম।
Ja, comunicação oral.
Este bathroom থেকে না তোমার আগে হলে তো আমার আরো আগে হয়ে যাবে। না না আগে হবে না, 6টা মনে ছিল তো 5:30টায় হয়ে যাবে। এর আগের টাইমটাই ঠিক। কিসের থ্রুতে জয়েন করলে? এমনি ডাইরেক্ট গুগল এখানে ক্লিক করো, ক্লিক করে নাম টাইপ করবে আর একটা ক্যাপচা থাকবে, বাস। তুমি হোয়াটসঅ্যাপে আছো?
تعال معايا في الكونفرنس ده.
ভিডিও অডিও ডাউন করে দিই। দুটো জানে কি করবো, সমানকে বলবো। কই দেখি এটা?
Hello? Hello? আমাকে দেখতে পেলাম।
بقوا 15 بارتيسيبنت. بقوا 15. ايه هو في حاجة تانية؟ ثلاثة ولا
Hello?
Hello?
Hello. Here, Dr. Ivana Halushkova from Paris. So we are now started conference.
Hello?
Can you hear me?
Yes, yes.
Yeah. Okay.
Nice.
Great.
زاد ايه سيبنا نتكلم مع بعضنا ولا ايه؟
The line. Try to log in there. But you got a Zoom link. Yeah. No, they sent through WhatsApp only. No, I didn't send any link. They send only the ID and password. Only that I use now. Yeah, I use that and open. You log in on Zoom. Because today morning she was doing. Even Zoom.
مش صدى؟
Started here. No, no, no. It's only the
بقول
live
لك اقفله احسن عشان ما يعمليش صدى.
That's the Zoom. Hello.
Hello.
Yes. Yeah, it has one HVS. I have to give it to you. Okay.
لقيت تزميل. بس هم عشان ما عندهمش سكيدول كتير. في دلوقتي بتختلف من بلد لبلد، فعشان كده هنبدأ
Osaka. Osaka. Ndị India. Before to leave, you can leave.
Hello. Yeah, sir. So, very good morning as well as good evening to all of you. Myself, Mr. Madhu, representing Innovine Conferences, welcomes all distinguished guests, doctors, scientists, educators, colleagues, friends, and ladies and gentlemen. It is a great honor for me to welcome all to join this event on behalf of organizers of the virtual conference of infectious disease 2020. I would like to express my hello. I would like to express my sincere gratitude for your. Yeah, sir. We are going to. Doctors, scientists, educators, colleagues, friends, and ladies and gentlemen. honor for me to welcome all occurrence events on behalf of organizers of the virtual conference on Infectious 2020. I would like to express my sincere.
Please, the voice is very low. I can't hear.
Same thing for me, I cannot hear you. Can you increase the volume, please? Thank you.
Good morning to all. Shall we start the program? First talk, Mr. Dr. Nahla Khamis Ibrahim, King Abdulaziz University, Saudi Arabia. Title: Epidemiologic Surveillance for Controlling COVID-19 Pandemic, Types, Challenges, and Implications. Hello, Doctor.
Hello?
Dr. Nahla? Yes, shall we start?
Hello?
Yeah, hello.
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 Hello, everyone.
Hello.
Good morning, good afternoon, good evening, our dear colleagues. It is a great pleasure for me to come with you in this such important conference of infectious disease. I take a great pride in welcoming all of you in this infectious disease conference, and I will start my talk about a very important topic, which is COVID-19. I am Professor Nahla Khamis, Professor of Epidemiology and Public Health at King Abdulaziz University and Alexandria University. I am an Egyptian epidemiologist. I am graduated from Faculty of Medicine, Alexandria University. I have 2 degrees in epidemiology, master and PhD, and 2 degrees in medical education. I am peer reviewer in several international conferences, including WHO, Saudi Medical Journal, Epidemic Journal, Clinical Epidemiology, and journals. I am selected as one member of Who is Who Encyclopedia, as one of, alhamdulillah, pioneer person in my specialty. Today I will speak about the epidemiological surveillance for controlling the COVID-19 pandemic, types, challenge, and implication. Now I start my introduction. Currently, the whole world is struggling and facing the era of eco-epidemiology. There is emerging and re-emerging of numerous devastating infectious diseases. Emerging diseases are those appear for the first time during the past 2 decades. The emerging viral zoonotic diseases, which are always zoonotic, outbreaks are growing in number. Severe acute respiratory syndrome, SARS, H5N1, influenza A, H1N1 pandemic, and Middle East respiratory syndrome, coronavirus, MERS coronavirus are among the most important infections. All of these infections and others like Zika, H7N9, Ebola had serious public health implications. SARS-CoV-2, severe acute respiratory syndrome, coronavirus 2, causing COVID-19, is one of the most important devastating emerging infectious disease nowadays. COVID-19 was classified as a public health emergency of international importance on 30 January 2020. It was characterized as a pandemic by the WHO on 11th March 2020. SARS-CoV-2 was classified as a pathogen with risk group 3, as it carried a very big risk for the community due to its huge effect on health and global economy. COVID-19 was first identified during an outbreak of respiratory illness cases, pneumonia, which occur in Wuhan City, Hubei Province, China, in the fish market. And then it rapidly growing till it becoming a pandemic and spread all over the world. COVID-19 pandemic leave huge devastating burden on health, lives, economy, with restriction of the whole population societal activities. It caused both global and economic crisis, with countries shutting down their borders and issuing travel bans, closing school and business, and imposing strict quarantines and more. Now, what are the causes of occurrence of COVID-19 pandemic? Why it occur in pandemic 4? For occurrence of pandemic, there must be a criteria. To occur, then it will occur as a pandemic. The first one is the global spread of newly SARS-CoV-19 without any previous exposure or immunity. The second one, SARS-CoV-2, is an RNA virus which exhibit high mutation rates. The third one, the virus transmission rate or basic reproductive number R0 is high. It starts at about 2, then it reaches about 4. Once it will reach less than 1, the pandemic will be stopped. The fourth factor is up to date. Until now, there is no available effective treatment nor vaccine exists for COVID-19. All those 4 factors causing the pandemic, causing the occurrence of pandemic. COVID-19, most of people of COVID-19 develop only mild and uncomplicated illness. About 80% of the cases is usually mild and uncomplicated and usually not apparent or diagnosed as common cold and so on. Approximately 14% develop severe disease, require hospitalization and oxygen support. Only 5% require admission to intensive care. In severe cases, COVID-19 can be complicated by acute respiratory distress syndrome, sepsis, septic shock, multi-organ failure, including acute renal failure and cardiac injury. Older people and those with other comorbidities as cardiovascular diseases, diabetes mellitus, obesity, COPD, cancer, and sometimes smoking have an increased risk of severe disease and mortality. This diagram shows the cases and in apparent cases. The mild case, it is like an iceberg. With the tip of iceberg is the apparent cases, apparent COVID cases, which usually go to the hospital, which is a clinical case, which is about only 1/5, and the 4/5 is floating cases, not apparent, with mild asymptomatic or asymptomatic infection, which is also transmit the infection. So the cases, the clinical cases, is the tip of iceberg of subclinical cases, which is very dangerous. The magnitude of the problem until now, on 20 September 2020, there is a total of about 30 million cases all over the world. The total recovered case is about 22 million, about 73%, and the total this is approaching 1 million, giving a case fatality rate of 3.1%. The fatality rate is not so high, not like MERS, which is about 34%, or not like SARS, which is about 10%. But the main dangerous is due to very rapid spread due to high reproductive number or reproduction number. This is the cases today from the WHO site dashboard. The highest rate, the highest number of cases in Americas, in region of Americas, about 15 million cases, with the highest country in USA, which are approaching 7 million cases. The second is Southeast Asia, with 6 million cases, then Europe, Eastern Mediterranean, Africa, and Western Pacific. This is the chart, which is Americas and Southeast Asia and Europe and the Eastern Mediterranean. I think that Africa may not adequately reported the number of cases. Now, in absence of vaccine and the treatment and all things about COVID-19, the only control measure is through epidemiological surveillance. What is the epidemiological surveillance? Surveillance or epidemiological intelligence is the ongoing systematic collection, analysis, interpretation, and dissemination of data regarding a health-related event. Or the shortest definition is collection of data for action. COVID-19 surveillance involves monitoring the spread of the disease in order to identify the pattern of disease early and stop it. In spite of the effort of enhancing epidemiological surveillance, developing nations still have difficulty in accurate identification, diagnosis, and reporting of communicable diseases. This is the stages of surveillance start from data collection of the disease like COVID, data analysis, interpretation, dissemination, and link to action and control. What is the importance of surveillance? Surveillance is the cornerstone of any prevention and control program. Surveillance is a crucial part of public health practice. Results of a study reported that if measures in China had been started 1 to 2 or 3 weeks earlier and reported it earlier, the cases could be reduced 66, 86, and 95% respectively. This finding magnifies the importance of surveillance in controlling COVID-19. The objective of the current study was to determine the types, challenge, and implication of surveillance method used for controlling the COVID-19 pandemic. The method, an integrative review was conducted. The method of this integrative review, including articulation of the problem regarding surveillance of COVID-19, completion of well-defined literature search, evaluation of quality of data, analyzing data, presentation of conclusion. The first step was a clear identification of the problem, which is epidemiological surveillance and COVID-19. Literature search was clearly addressed, the subjects such as search terms, the source used, and the inclusion and exclusion criteria. The sources of information were documents from WHO, Eurosurveillance, CDC, Center for Disease Prevention and Control, Saudi CDC, Ministry of Health, and journals through PubMed and Medline and others. The search term, including surveillance, COVID-19, magnitude, indicator, challenge, and benefit or implication. Regarding the inclusion criteria, all published guidelines review studies that assess the surveillance system and surveillance in COVID-19 during the period from 2005 to 2020 were selected. For evaluating literature, grading quality of the included article was done using the University of Michigan practice guideline level of evidence level hierarchically for grading of evidence. Analysis of different sources was done and presenting in 3 main themes. The first one related to summarize the aim and types of surveillance. The second one is about the indicators and the implication. And the third one is about the challenges and the limitation of surveillance. Now we reach our results. My paper was published in the Journal of Infection and Public Health, which is a good journal with a good impact factor, which is entitled Epidemiological Surveillance for Controlling COVID-19 Pandemic. It was published in August 2020, in the last month. And this is the reviewed article, which is scrutinized and given, the level of evidence was given. Now I will present the results of aim of COVID-19 surveillance. The aim of COVID-19 surveillance, global surveillance, at first one, to monitor the trend of COVID-19, where human-to-human transmission occur. Second one is rapid detection of cases, country where the virus is not circulating. Then to provide epidemiological information to conduct risk assessment at national, regional, and global level. Provide epidemiological information to guide in preparedness and response measure for COVID-19. Monitor viral changes to inform drug and vaccine development and to identify marker of severe infection. Now I will speak about the types of COVID-19 surveillance. At first, the first group is routine surveillance. There are 3 types: either comprehensive routine surveillance, case-based routine surveillance, aggregated routine surveillance. Comprehensive routine surveillance, this type of surveillance deals with complete testing of all suspected individual. Of course, it is very costly because they test all suspected individual. It uses the number of newly confirmed cases per 100,000 of population. It is the most accurate indication of COVID-19 intensity. It can measure the geographic spread and severity of COVID-19. Such surveillance can be used to monitor the trend by time and to compare between intra-country data. The second type of routine surveillance is case-based surveillance. The WHO requests report of probable and confirmed cases of COVID-19 immediately after identification within 48 hours. An update need to be provided regarding the outcome data after 30 days to see the outcome of the case, either death or recovery or complication. There must be update. The surveillance data can be applied by most of the countries. Such surveillance data, which is case-based, can be applied by most of the country. The drawback of such type, if applied alone, is losing the opportunity of early diagnosis of many COVID cases. Hence, no measures will be taken, or not applied for the contact, which lead to further spread. The third type is aggregated routine surveillance. For this, it is required to give weekly report about newly confirmed case, newly case deaths for COVID-19, newly case hospitalized, newly confirmed cases discharged, newly confirmed case tested by COVID-19 by age group, newly confirmed deaths by age group. Again, the drawback of such a type, if applied alone, that it lost early diagnosis of COVID and taking care of contact. The fourth important type is active surveillance. Now we reach active surveillance. It deals with active search for the disease in certain population. The WHO recommends such a type of surveillance for case finding, testing, and contact tracing. All countries need to quickly strengthen COVID-19 active surveillance for fast recognition of infected person and to allow prompt isolation and quarantine. We can quickly locate and talk with the affected individual, assist in isolation issue, identify close contact, and help those who need self-isolation or quarantine. Self-isolation for the case and quarantine for the contact. But who is the contact of COVID-19 cases? Contact
Sorry, may I ask you, because you are speaking and I can't stay very long to be connected. I am Dr. Ivana Halushkova from France. You were mentioning that you are looking for there are three types of the surveillance, and I totally agree that the surveillance is a key for any diseases. This is not the first, neither the last, as you mentioned. There were Ebola, there were SARS, there was MERS, and now we have a COVID, and we might expect other diseases to be upcoming because the source is zoonosis, as you correctly said, but also the climate issue. We are looking now even in France, in Europe, in a very high rise of the dengue, Zika, malaria, vector-borne diseases. And not only this, so there are a lot of comorbidities which I would suggest that need to be collected as a factor which are influencing the immune response. So, and in addition, I am wondering, because there are so many diagnostic tests that sometimes they don't distinguish if the patient actually is infective or has healed. So, and then the third question or point is that it's still not yet clear if the immunity, once you get healed, is getting cross-protection for the mutated virus. So it's very important to collect the virus and analyze the virus and mutated strain, and to have a very good local, regional, and global laboratory networks which are able to handle the virus, but monitor also the comorbidities, because the African countries, South Asian countries, and even in America, in South America, the countries are facing other infectious diseases in the same time, and non-infectious diseases like cancer, diabetes, which you mentioned, which influence the immune capacity to respond. And finally, there is a very big risk factor or factor which is showed very clearly in France: immunization rate, basic immunization rate, like BCG, rubella, and other. The basic calendar needs to be maintained, because it seems that the children up to 14 seems to have a better protection, less fever casuistic, less hospitalization, and the schooling, which allows to exposure to other respiratory diseases, enhance the response to other potential viruses or pathogens, because it's not only about antibodies, it's also about long-lasting cell response. And finally, there is a French vaccine which shows indirect cross-protection effect due to cellular innate cell training, and other vaccine ongoing, which need to be proved. But I, as a physician, ID physician and immunologist, I do know perfectly that the time and the science is very linked, and the vaccine development is very complex to be sure that it's safe and effective. So there will need to be a surveillance for the safety and the efficacy of vaccine, because the data are not such robust as for the older vaccine like BCG. Concerning the treatment, and concerning the treatment...
Thank you, Doctor, but can we discuss after I finish my talk, please?
Hello, Doctor.
Very last, because I have to catch the the plane. So very last point, that there are two treatments ongoing, and one is coming from India, actually Ayurveda. The base is the immune response and identification of the correlate of protection for successful vaccine. So it would be great if we are not measuring just antibodies, which are vanishing with the time, but also we learn collecting within the surveillance laboratory network the immunology parameters. This is what I wanted to mention, but your presentation is crucial. We have to take a lesson also for the next manage now, because the economic and the sanitary crisis is just terrible, and societal crisis.
Okay,
but
thank you
we
very
have
much. Thank you very much for this comment. But we need to make the discussion, please, after I finish my talk.
Yes, but
you have very nice points regarding BCG vaccine.
I definitely will. I would like to follow with you. I will leave my mail, because I said I'm catching the plane, so I can't stay. I'm sorry, but this is totally crucial.
If you have any queries, just you can mention in the chat box, so that we can convey this.
I will send to organizers my email address, because now I am connected with the phone. But there, I said 3 main points: surveillance, preparedness, and effective rapid detection and action, because this is not the last one, and managing the current situation as
but this
we
is
can
not
do.
A reason to disturb the conference. The way you are intervening in the middle of somebody presenting, I don't think that this is acceptable.
Yes.
Yeah, I apologize, but the only reason is that I have to leave. That's why I'm sorry.
You cannot do this.
Yes, Doctor Mahela, just you can continue your talk, because I cannot run.
Okay. Contact is defined as any person of any of the following exposure: being within 2 meters of confirmed COVID-19 cases for more than 15 minutes, direct physical contact with the confirmed COVID-19 cases, providing direct care of confirmed COVID-19 cases without using proper personal protective equipment, living in a household with a confirmed COVID-19 cases, sharing a room, meals with other space with confirmed COVID-19 cases, sitting within 2 rows of confirmed COVID-19 cases for more than 15 minutes, and at any crew in direct contact with the case at public or shared transportation. This is the definition of contact. Anyone has such criteria is a contact. This is the definition of contact. So after we discover the case, what are the measures we apply to the contact? At first, we need to test if we do active surveillance, need to test the contact using nasopharyngeal or oropharyngeal swab, and better nasopharyngeal. Or we can take from respirator if intubated for COVID-19, preferably within 24 hours after exposure. They should be followed up daily after that for 14 days. 14 days, what is the 14 days? 14 days is the longest incubation period. The incubation period is 2, so I follow up the contact for the longest incubation period, which is 14 days, and I quarantine them. If negative on the initial testing, exposed patient should be retested with PCR if they develop symptoms suggested of COVID-19. Contact discharge during the follow-up period must be reported to Public Health Department to continue monitoring for symptoms. So contact tracing is very important. Contact tracing is the key for slowing the spread of COVID-19 and help to protect you and your family and the community. Letting people know that they may have the infection, may have exposed to COVID, and should monitor their health for sign of COVID. Helping people who may have been exposed to COVID-19 to get testing, and asking the people for self-isolation and self-quarantine for the longest incubation period, which is 14 days. This is form brought by Ministry of Health and Saudi CDC for follow-up of contact for the 14 days. If every day public health worker or even volunteer doctor ask a group of contact about them every day, regarding fever, shortness of breath, sore throat, cough, headache, muscle pain, diarrhea, vomiting, runny nose, and other, for 14 days. And if there is any symptom appear, the case may be considered as suspected case of COVID-19. This is the contact tracing, which help us so much after quarantining for decreasing infection. The fifth type of surveillance is syndrome or clinical surveillance. This means surveillance of health data about clinical manifestation. Here we deal with clinical manifestation that has an important impact on health. On March 2020, the WHO recommended case definition of COVID case. What is the COVID case? We have either suspected, probable, or confirmed case. Suspected case is the patient with acute illness, like fever, acute respiratory illness, like fever with at least one symptom, as respiratory distress, cough, shortness of breath, and the history of travel or residence in location which COVID transmission occurred or have seen a COVID patient within 14 days, or a patient or a person with any respiratory illness and having been in contact with confirmed case within the last 14 days, or a patient with severe respiratory illness required hospitalization in absence of alternative diagnosis that fully explain the clinical presentation. This is a suspected case. Then we need to confirm the case using the PCR. The confirmed case is a person with laboratory confirmation of COVID-19 infection, irrespective of clinical manifestation and symptom. Laboratory confirmation is done using 2 samples of real-time polymerase chain reaction, PCR, through various specimens, preferably nasopharyngeal and maybe oropharyngeal. The challenge of this type of surveillance, which is syndromic surveillance, is the cost of testing, especially for confirmed case, is the cost of testing, which has also require high biosafety level. The 6th and 7th type of surveillance related to sentinel surveillance. Sentinel surveillance is a network of healthcare providers or hospital that are recruited for regularly collected data about COVID-19. The reporting unit have a high possibility of seeing the patient, having good laboratory facilities and qualified staff. Such a type of surveillance is used for promptly understanding the magnitude in the population. The drawback that it is based on sentinel units or sentinel hospital. The seventh type is sentinel syndromic surveillance, swab obtained by sentinel physician from a systematic sampling of cases presenting for influenza-like illness, acute respiratory tract infection, which is needed also to test for SARS-CoV-2. Then we have laboratory-based surveillance. We have three types, which either virological sentinel, and population-based. For virological surveillance, it is done by molecular testing of COVID-19 by PCR. Virological sentinel, it is based on using clinical specimen that obtained through national sentinel surveillance of influenza-like illness, acute respiratory infection, severe acute respiratory infection. The third type of virological is population-based, as in UK. Here, healthcare practices collect blood sample from persons coming for a routine blood testing. I think it is very high cost. They are asked to give extra sample for COVID-19 serology. This is done from UK. It is population-based. For all person, give sample. Then we have hospital-based types of surveillance. In hospital-based surveillance, the first type is hospital-based surveillance for severe acute respiratory infection. Nation with no longer test a mild case, not do active surveillance for COVID, must be at least test severe acute respiratory infection, which admitted to hospital or intensive care unit or high dependency units. These countries need to monitor the percentage of confirmed cases of COVID from all severe acute respiratory infection. Sentinel hospital need to be chosen if catchment population is recognized. The challenge of this type is related also to the hospital. Then, routine surveillance for nosocomial outbreaks. There may be outbreak, hospital-acquired infection or hospital-acquired outbreak, which is very dangerous, which may occur related to COVID-19. Infection can cause outbreak in hospital. COVID-19 infection, nosocomial infection, must be notified within 24 hours of detection, which is class 1 reporting, must be notified immediately. This surveillance lead to quick manage such events, enhancing infection prevention and control. It lead to contact tracing for protecting healthcare worker, patient, and residents who are at high risk of severe disease. In addition, such approach lead to preserve the essential healthcare infrastructure. If the number of COVID-19 outbreaks and the proportion of affected facilities may be used as supplementary indication of intensity and geographic spread, this type can be used as intensity. If I know that there is large hospital-based outbreaks or nosocomial, this means that the intensity is high. Example of outbreak of COVID-19 in hospital. In South Africa, in St. Augustine Hospital, there is an outbreak occur from 9 March to 30 April. A total of 119 confirmed cases identified, 39 patients and 80 staff, and 15 deaths occur among the elderly. They found that lack of separation of potentially COVID-19 infected person caused this outbreak. It was probably beginning in emergency room and lead to nosocomial outbreak and claiming and affecting many cases and cause 15 deaths of patients and the doctors. The third type related to hospitalized cases and the hospital is enhanced surveillance of hospitalized cases. It depends on hospitalized patient. For example, in Singapore, an enhanced COVID surveillance was applied by testing all patients with pneumonia, all patients enter in hospital with pneumonia, all intensive care patients, people who died for unknown cause, and individual with influenza-like illnesses. Suspected patients are also tested according to clinical and epidemiological reason. Such surveillance is very important type to detect new cases, but the challenge is the case detection method were primarily based on symptomatic cases. This is enhanced surveillance. Risk group need to be recognized and followed up. Such surveillance type can collect data about the patient age, sex, treatment, underlying disease, smoking status, intensive care admission, clinical outcome, and healthcare worker status. The fourth type, which can be applied in hospital and healthcare facility, is mortality surveillance. Surveillance of this from COVID among hospitalized cases remain vital for measuring the severity of disease, for calculating the case fatality rate. Such data is also easy to collect. However, mortality data can't mirror the correct COVID-19 related mortalities in the population. Long-term care facility surveillance can be also used among elderly who die outside the hospital. Then there is healthcare surveillance. Such type notify the effect of COVID-19 on capability of healthcare system. It gives information concerning the availability or lacks of essential resources like ICU beds, ventilators, personal protective equipment, and the healthcare personality shortage. Those are 5 types related to hospital. Then we have surveillance of wildlife. It was needed in China at the start for identification and the characterization of possible reservoir and source of infection. Surveillance among people who in contact with wildlife is important to recognize behavioral risk factors that cause COVID-19 and other factors, other diseases. It can prevent further pandemic. This surveillance of wildlife, even killing bats in caves, is very important. And very important to ban some foods and some food habits like eating bats. Dealing with wildlife may carry high risk of transmission of COVID-19. So this requires high level of biosafety. Improving biosecurity regarding wildlife trade and closing illicit markets is important. Now, the new era for surveillance is media, electronic, and digital types. There are 4 types. The first one is helpline survey and participatory surveillance. Nation who is not routinely tested the majority of suspected cases use another method, like using a consultation call with sentinel doctor, call of healthcare telephone helplines, consultation of online health, self-assessment tool for advice of COVID-19 testing. Then other technological related surveillance is event-based. The capacity and for rapidly detect any change in overall COVID situation can be further strengthened through event-based mechanism, through capture unstructured information from formal and informal channel like online content, radio broadcast, and print media across the relevant sector to complement the conventional public health surveillance effort. Then electronic reporting system. It used web-based tools for reporting the disease and the epidemic. Such surveillance can improve the quality and timeliness of epidemic and timeliness of surveillance reporting for this epidemic. Electronic record, dashboard, and the other electronic tools are needed to assess surveillance system. For electronic in USA, for example, there is CDC utilize interactive germ data dashboard, bioinformatics in cloud, application of program interface, and others, like smart technology. In KSA, there is Health Electronic Surveillance Network, which is HESN, which is established in 2014. And it utilized nowadays for rapid reporting, updating, and giving feedback about COVID-19 cases. Then we reach the digital surveillance. Digital surveillance are being used to support the public health response to COVID-19 worldwide. It includes population surveillance, case identification, contact tracing, evaluation of intervention of basis on mobility data, and communication with public. Many countries utilize digital surveillance, including apps, location, and electronic tags for COVID-19 pandemic. These are some examples of digital surveillance. The first is ankle bracelet, which is used for USA to enforce the quarantine among the COVID-19 patient and to avoid violation of this quarantine. The second is wrist bandage. In South Korea and in Saudi Arabia and many other countries, the GPS apparatus was used to track location of isolated person for sending alert to authority if the people leave the chosen area. Here in KSA, there are many digital form used in surveillance for follow-up. There are many methods for contact tracing, mobile use, and surveillance. Rest assured, برنامج تطمن for investigation, mobile health support, rest assured, and many other technological methods used for surveillance of cases and contact, and for confirming the isolation of cases and the quarantine of contact. Now we reach summary of types of COVID surveillance. We have 3 routine types: comprehensive, case-based, and aggregated surveillance. Comprehensive need complete testing of all suspected case. Case-based report COVID-19 immediately after identification. Aggregated type, which weekly report of all COVID cases and deaths. Active surveillance, active search and contact tracing. Syndromic surveillance for surveillance of health data. Sentinel surveillance, healthcare provider or hospital are recruited to regular reporting about it. For laboratory surveillance, virological, sentinel, and population-based. For hospital, 5 type, hospital-based for severe acute respiratory infection, routine surveillance for nosocomial outbreak, enhanced surveillance, mortality surveillance, healthcare surveillance, and surveillance of wildlife. For media and electronic surveillance, there is helpline, survey, electronic reporting system, digital surveillance, and event-based surveillance. Now we reach the analysis of surveillance indicator from COVID-19. Surveillance indication for monitoring COVID-19, indicators of transmissibility, seriousness, and the impact of COVID-19 are vital. Some indicators can help in informing about the measures that need to be taken, as social distancing and quarantine. The evaluation of outcome of hospital must depend on bed occupancy in wards and intensive care unit and the capability for ventilation. The indicators can inform a decision maker about the healthcare supply requirement and guide towards shifting or enhancing capabilities. Further indicators to assess the effectiveness of containment measure need to be calculated. The usual surveillance indicators as sensitivity of surveillance, specificity, timeliness, and completeness of surveillance report can be also calculated and usually calculated. Now we reach the implication. What is the importance of COVID-19 surveillance? Nowadays, efficient surveillance is highly needed for collecting information and doing action, and hence controlling COVID-19 pandemic. Surveillance data give us picture of reality and inform decision about the situation. It is useful for early detection of COVID-19 cases, application of case management protocol, and doing containment measure. Early detection is successful for treatment. Such early detection is successful for treatment and further stop transmission. Exploring and using the open source, web-based source to modernize the mortality data is very important. Surveillance can influence the timeline of policy application, public risk perception, and decision-making. All levels of government and healthcare system need details and timely information about the availability and shortage of resources. This can slow COVID-19 growth or even ending the pandemic. Now, what are COVID-19 surveillance challenges? Public health challenges in low resources countries differ from the surveillance in developed countries. There are many challenges for application of efficient surveillance in developing countries. The first one is that more must be done with less. The second challenge is that strengthening the surveillance system in these countries is more complicated due to deficiency of resources and lack of adequate training. The third one is that the sustainability of the surveillance, which is more challenging. There is in addition, there is major underassessment and underreporting of total COVID cases. There is big uncertainty regarding and due to lack of longitudinal studies and clinical trials. COVID-19 surveillance is also limited as mild and subclinical cases are usually not seeking treatment, which is floating cases, which is the main part of iceberg. Furthermore, mild cases usually avoid the hospital unless it is necessary. The testing capacity may be also limited to only severe cases. In conclusion, surveillance is one of the cornerstones for controlling COVID-19 pandemic. There are many types of surveillance: routine surveillance, active surveillance, sentinel, and are some types. Laboratory, hospital-based are another types. Helpline survey and participatory surveillance, electronic and digital surveillance, and event-based are cost-benefit types for depending on media. Surveillance of wildlife was needed in China at the start of pandemic and for detection of behavioral risk factors. Surveillance is needed as any missed case of COVID can lead to new chains of transmission and the more difficult containment. Many surveillance indicators can be calculated as transmissibility, seriousness, and the impact of COVID-19. Other important indicators based on evaluation of COVID outcome on hospital sensitivity, timeliness, and completeness need to be calculated. There are many challenges facing the application of COVID-19 surveillance. These challenges are mostly related to cost, training, and sustainability. Other limitation of surveillance is mainly related to COVID-19 underassessment and underreporting, and lack of timeliness and completeness of the report. Now we reach our recommendation. The first recommendation is to enhance epidemiological surveillance of COVID-19, which is a crucial tool for rapid case detection and containment of the spread, enabling public health authority to manage the risk of COVID-19, allowing economic and societal activity, and monitoring the longer-term trend and changing of the virus is important. Adoption of multiple and complementary surveillance system can ensure broad coverage. Regular evaluation of the surveillance system to ensure that COVID-19 is monitored efficiently and effectively is needed. Designation of laboratory to implement tests for rapid, accurate diagnosis and early detection is very important with high level of biosafety. Adopting new technology to improve surveillance accuracy and spending reporting of disease are required. More training is needed for public health surveillance officers and volunteers to implement the most promising practice on the use of technology. Apply active surveillance. Use of more innovative method for data collection will add important value in controlling the pandemic. The design of surveillance system need to be appropriate for each country. COVID-19 surveillance should be dynamic. It must be sensitive enough to detect every COVID new case. It should be specific to identify problem and focus resources. It must be flexible and connected to protect people locally, nationally, and globally. There is a need to control coronavirus based on biosecurity regarding the animals, as well as a shift in food habits with banning of wet markets. We are now at the start of new era for new digital and electronic surveillance, and we need to continue in this era. We must be prepared to handle COVID-19 challenges of today, and at the same time to make real potential of new innovative technology. Last but not least, we must stay together against COVID-19 with all language. We must stay apart to stay together in English, in French, and in every language. This is my references. And last but not least, we need to stand together against COVID-19 and other emerging diseases. Thank you very much for your kind attention. Yes. And I really proud to be in this conference. Thank you.
Yes, Doctor. Thank you. Thank you.
2 minutes.
Thank you very much, Doctor, for giving a valuable, stimulating speech. Thank you for always speaking up in a team meeting and providing a uniform. So if you have any questions, just you can ask to Dr. Camilla. Any questions or comments from your participants? Just you can raise your hand, or just you can keep text in what chat if you have any questions. Okay, thank you very much, Doctor.
Thank you very much. Thank you.
Yes. So next we welcome Dr. Shampada Mondal, Laboratory of Microbiology and Experimental Medicine, University
yes,
of
sir.
Yes, University of Baga from India. Well, yes, sir. You can join the event. You can start playing PPT.
So is it opening?
Yes, sir. Just you can enlarge it.
Sir, is it okay, the display?
Yes, sir.
Sir, can I start my speech?
Yes, sir.
Yes, very good day.
Yes.
I am Professor Shamapanda Mandal from Kolkata, West Bengal, India. My speech is on the title Indigenous Lactobacilli, Probiotic Features, Safety Profiling, and Antagonistic Property against Human Pathogenic Bacteria. So before going to main item of the speech, we have to discuss some points on some focus. That is why we will study on probiotics locally, because probiotics are very good biotherapeutics agents applied broadly around the world, and these are non-harmful, these are grass in nature, and can be procured from fermented foods such as curd, as well as from human biological samples such as stool. And these probiotics may show different types of stress tolerance capacity, such as tolerance to sodium chloride, bile salt, and temperature, as well as they are non-toxic. They show antagonistic activity against different types of pathogenic bacteria that may be gram-positive and gram-negative, causing different types of infection to humans as well as other animals. And they secrete different types of antibacterial agents, mainly hydrogen peroxide, organic acids, and above all, the agent is bacteriocin. So we have focused our study on probiotics lactobacilli that were isolated from locally available food sample as well as stool from infants, and we have isolated their bacteriocin that are antibacterial in nature, that are proteinaceous in nature, as well as finally we have tried for the combination study, that means lab combination against biotic resistant bacteria as well as lab-bactericin in combination with antibiotics against antibiotic resistant bacteria in order to combating the MDR infection to humans. And finally, we have conclude with some precaution. And so this is the background. We know the probiotics have a multifaceted action. That means not these are living in the intestine and not maintain only the intestinal health but also oral health. They may be anti-cancer, anti-diabetic, anti-depression, vitamin synthesis capacity. They can cause production of high amount of antibody against pathogenic infection. So probiotics, these may be defined as live microorganisms and that must be administered in adequate amounts and to get the health benefit on the host. Basically human, but may be applied in other animals such as birds, cows, etc. And for their activity displaying, that means the probiotics, such kind of activity they display, but behind that some substances are required by the probiotic microorganisms. These are known as prebiotics, which is a substance that are selectively utilized by the host microorganisms, which are beneficial and conferring health benefit to the human host. Such kind of some substances are glucans, fructans, polyphenols, starches, and pectin. These are very much required for the growth and maintenance of probiotics in different kinds of environment, externally as well internally in the human intestine. So this is the mechanism in the background, how these probiotic microorganisms work in combined way, not in single way. These are represented here, such as the probiotic, the lactobacilli mainly we will focus. There are many kind of microorganisms, bifidobacterium, leuconostoc, fecali bacterium. These are newly derived. They display tridirectional communication. That means they interplay between host cell, different kinds of, mainly the immune cells in the host body. And in the intestine or other parts, several types of bacteria may be beneficial or pathogenic. They are colonizing for their lifespan inside the human host, mainly in the intestine. But probiotics show different types of mechanism and exert action on the pathogenic bacteria and reducing their number in the niches, in different kinds of niches inside the human host, so that the number is maintained. And the first one, their activity is modulation, immune modulation. They increase the secretion of amount of antibody so that the antibody act against pathogenic infection, reducing the infection capacity of the bacteria or virus or fungus or bacterial antigen or parasitic antigen. And they also reduce the amount of pro-inflammatory stimulation, that means cytokines, as well as increase the capacity of phagocytes by the phagocytic cells inside the human body of the immune system, and improve barrier function. So if we consider barrier function, we know the probiotics help in gene modulation. The gene of mucus secreting genes are activated so that large amount of mucus are secreted when need, and the pathogenic bacteria cannot thrive over the good bacteria, that means probiotic lactobacilli, as well as they cannot colonize. So what is colonization? This is colonization. Colonization means the establishment of bacteria or other kind of microorganisms on a surface that may require for their living and continuation and their physiological action, either exert they pathogenically or beneficially. And here the probiotic bacteria secret, I say already that mucin, the mucin cover up the epithelial lining of the inner intestinal cell, and so that the pathogenic microorganisms cannot establish over the kind of cells, that means the epithelium cells, due to the presence of mucin. and their activity may be different types, probiotic host interaction. They actually need proteinaceous substance as well as non-proteinaceous substance such as pili, LPX-TG binding protein, mucin binding protein, or toll-like receptor ligands, lipopolysaccharide and exopolysaccharides. These are non-proteinaceous in nature. And if you see their interaction, the gut microbiome, I have already told that in the gut there are different kinds of microorganisms. So, and with each microorganism, probiotic microorganism, that means lactobacilli have the capacity to interact. So how they can do this? They secret antimicrobial production. That means the maybe acid, different types of organic acid, hydrogen peroxide, as well as bactericin, which have told earlier, and they support thus the microbial balance in the gut. And also they produce organic acid and due to the problems of lactate, propionate, and acetate, three kinds of acids, the pH of the intestinal environment is reduced, and so that the other kinds of pathogenic bacteria cannot thrive within this pH, but probiotics can. And another is butyrate through cross-feeding. What is this? We know Bifidobacterium is a good probiotic as well as lactobacilli. These can synthesize very readily the lactic acid but cannot butyric acid, that means butyrate, but that can cross-feed to Faecalibacterium so that the bacteria, Faecalibacterium as a good bacteria, secrete butyric acid, which is responsible for the prevention of metabolic disease of cardiac system. And on the other hand, we have seen that different types of molecules, macromolecules secreted by such probiotic microorganisms such as cortisol, serotonin, and GABA. These substances are required for the well maintenance of physiological capacity of the host, and they also secrete tryptophan and histamine derivatives. Satiety hormones, that means phrelin, these are secreted, and the appetite is maintained, and sleeping capacity is maintained, and conjugated linoleic acid. And ultimately, we know some enzymes are secreted by the probiotics, of which the main is lactase. What is the function of this lactase enzyme? We know some individuals are lactose intolerant. That means they cannot tolerate lactose. Why? They cannot digest the lactose. But here, the lactose secreted by the probiotics digest the lactose to glucose and galactose. And bile salt hydrolase, what do this? They cause hydrolysis of bile salt and thus reduce the blood lipid profile and reduce the risk of heart disease. So this is all about the background of the introduction, and now we are already within the main topic of the speech, which is the probiotic bacteria procurement. That means isolation and therefore also identification, because we know the identification criteria is also a good criteria and a prime one in order to select the bacteria as a probiotic. So what we have did we have utilized two different types of sources, the fermented food in the form of curd and the infant stool. And after collection, these samples were inoculated into MRS broth, and MRS broth culture we have followed for 48 hours to 72 hours at 35 to 37 degrees Celsius, and thereafter we have seen the growth and then staked on the MRS agar plate. That means agar broth added with agar to solidify the media, and the strict dilution process was repeated to get the single colony, that means the pure culture of lactic acid bacteria on MRS agar, and thereafter we have followed for gram staining. And after gram staining from this culture, we have utilized TSI media, triple sugar iron, in order to see the utilization of sucrose, lactose, and glucose, and whether the bacteria is capable of producing hydrogen sulfide or not, or production of gas or acid gas in the form of carbon dioxide. And we also performed oxidase test and catalase test as well as indole test. So when it is seen that the bacteria is a gram-positive rod after the growth of MRS, the selective media for lactobacilli, this is a lactobacillus, because when it also shows the oxidase negative test, catalase negative test, as well as indole negative test, then these are rod-shaped such and such a type bacteria, and also non-spore forming bacteria. That means these are now considered as lactobacillus as genus. And for their identity at species level, we have followed different criteria such as biochemical tests, a panel of biochemical tests for the utilization of enzyme activity and carbohydrate. We have utilized 20 carbohydrates to see the degradation pattern or utilization pattern, and ultimately for species conformation, 16 sRNA gene sequencing has been done. And after getting the sequence, we have blast in NCBI gene bank with other kinds of similar bacterial sequences which are already deposited in the gene bank, and ultimately got the similarity, and we have prepared the phylogenetic tree, and 11 such bacteria we have isolated, and these are the NCBI accession number of the isolated bacteria and submitted to NCBI gene bank, which I have already told that we have matched blast the sequence of our interest bacteria, lactobacillus, after isolation, and when we got the similarity with other kind of bacteria, that seems that we have identified this, which is displayed here, Lactobacillus fermentum. This is a strain code we have that was given by us, and this is NCBI gene bank number. And
Hello. Yeah, doctor, please just, we are unable to hear your voice. Yeah, doctor. Yeah, Dr. Shampada Mandal. We are unable to hear your voice. Hello. Yeah, Dr. Shampada. Just we asked to unmute you. We are unable to hear your voice. Hello. Hello. Hello.
Yes, doctor, we hear your voice.
Yes, we are unable to hear Dr. Shampanda Mandal voice. I think due to technical problem, we cannot hear his voice. So we'll do one thing. Better we'll go to other talk. So if he's having problem solved with the technical one, we can start his program. Next we'll invite Dr. Gassin Karabi, Laboratory of Medical Epidemiology, First Institute of Tennis. Title will be influenza vaccination acceptance and refusal reasoning among the Tanzanian elderly. So now I welcome Dr. Gassin Karabi to join the event. You can upload your PPT and start the presentation, doctor. Hello. 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 Yeah. Yeah, doctor, and you, Bakora, you can start your presentation, doctor. Bukara, you can start your presentation. Hello. Hello. I think due to technical problem, we are unable to hear. Yeah, just we can go with. Hello. So we'll get some relaxation, doctor. Just a relaxation break. We'll have within 5 minutes. We'll rejoin the event again. Just we can have the break, 5 minutes break.
Hello.
Hello. Yes, doctor, we can hear yours. Just you can start your talk.
Yes, I'm trying to get the PowerPoint to be open. I can share. I'd like to share the screen.
Yes, you can start.
Good morning, everyone.
So just please upload your PPT, sir. We are unable to see your PPT.
I was looking at a way of sharing my screen.
Yes. Sir, if you are having problem with PPT, just you can share to me. Yes, sir. That's fine.
No, this is not this.
Just enlarge.
Hello?
Yes. Just enlarge the PPT, sir. Just we can see on from the screen.
But what is on the screen is not what I'm presenting. I don't see mine.
Yes.
Yes. Okay, no problem, sir. Please start your presentation.
Can I just talk on the audio only?
Yes.
Yeah.
Okay, thank you very much.
Just after that, after you're completing your talk, just you can share your PPT to all the participants.
After that, yes.
Yes.
Yes, I'd like to thank everybody for being here. This is a pleasure for me to be part of this conference. I would like to share with you the study that a group of researchers, of which I am the main member, has done in the Democratic Republic of the Congo. And the title of this presentation is Governance of the Riposte Against COVID-19, Ebola, and the Civil War in the Democratic Republic of the Congo, Ethical and Human and Health Rights Challenges. So this is a topic related to governance, and the general goal of it is to explore the issue of governance in terms of how the country has organized itself to respond to the COVID-19, for which the first case in the Congo was identified on March the 10th of 2020. And then alongside with that, the country has experienced different outbreaks of Ebola. And the first outbreak of Ebola known to have taken place in 1974, and then followed by 10 more outbreaks of the same. But all of these epidemics have taken place in a context of civil war. And this has made the situation very difficult. So for the country to manage the war, to manage Ebola and then to be confronted with COVID has been a real challenge. So we're talking about this topic because we feel it's important, and in the context of COVID. So the governance of the response against emerging infectious disease raises issues in the context of health and human rights, and also in the context of ethics. Quite often these challenges, these concerns have not been explored. And particularly, we have not seen interest in this topic in the Democratic Republic of the Congo. Yet, this is a country with most of the outbreaks that have occurred in the last decades. And also, this is a country with the unique experience of being the place where two of the main infectious disease has been considered to be coming from. I'm referring to HIV/AIDS, and also I'm referring to Ebola. I said this is a study done by a team. I am the main person on that team. My other teammates are from different institutions, in particular people connected with the Congolese healthcare systems. I can mention the name of my colleagues. Pinga Emmanuel Kabengele is based at the University of Geneva, but is of Congolese origin. We have Dr. Joshua Mwamba, who is an epidemiologist working in the response team for Ebola and the COVID. You have Dr. Chibang, who is a lecturer at the Faculty of Health Sciences at the National Pedagogic University in the Congo. And then we have Lucien Mujinga and David Mukeba. All of them, they are lecturers in the different institutions. And I'm glad that they were all available, willing to work with me for this study. At the outset, I would like to introduce the concept, the main concept of this study. So we are talking about governance, what it is, and we want to see what are the ramifications of good governance when we want to have one, in particular in developing countries. Governance is defined as establishment of policies and continuous monitoring of their proper implementation. This is done by the members of the governing body of an organization. It includes the mechanism required to balance the powers of the members. And this is referring to the associated accountability, and also their primary duties of enhancing the prosperity and viability of the organization or of the country, as we can say. The same concept has been defined also in relation to other settings like corporate business, where we see this reality of governance being defined as a body of rules and the practice by which a group of people called the board of directors will work to ensure that within the organization, within the corporation, there is accountability, there is fairness, there is transparency, and all the stakeholders that are part of the organization, those who are funding the organization, the customers who are buying the services or the commodities, the goods that are being manufactured by the organization, and people in management position, employees, everybody, government and the community, everybody has a way of deriving some benefits out of the operation of this corporation. So when we look at this, we can say that many ramifications can be considered in terms of how the different stakeholders, and in particular those in the position of board members, would operate. And in the context of a country, we'll say those in government, the Minister of Health, for example, for health-related matter, will be the one playing that role, or even the head of state, the president, may be involved in giving that strategic orientation, oversight of what is taking place, so that things can run smoothly and everybody can be satisfied with what is taking place in the context of operation of the healthcare infrastructures. So in terms of corporate governance framework, we can see some explicit and implicit contract between the company and the stakeholders. And this can be seen as being remote from our main consideration, health, but it is very important. When you look at the situation of developing countries, the tendency has been to rely quite often on the intervention of external actors. And these actors will play a role in providing some resources. And then in some cases, according to what is spelled out in the contract, they will be the one dictating some of the activities in the field. Another concept that is related to governance is the establishment of procedures for reconciling the sometimes conflicting interests and the stakeholders in accordance with the duties, privileges, and role that people can play. And we are referring also to procedure for proper supervision, control, and information generation. So we yes, now you can see me.
No, sir.
I'm being told that the host stopped me, but
yes, sir. Just you can proceed your talk, sir.
Okay. So that's some principles of good governance, and these principles have been discussed quite extensively in the literature, and also when people discuss what is taking place in different countries at the top level, they'll refer to that. They'll say, for example, things are not going right because we don't have good governance. So some of the principles that guide governance have been captured, and 12 of them are widely known. People say that the first one will be participation, representation, and fair conduct of election. So you have people who can be in that position only when there was a voice of the people coming through election. Another principle I'm sorry, I keep receiving a message for me to check the video, but I don't see a way of doing that. I'm sorry. So the second principle is responsiveness. And the third is efficiency and effectiveness. We want things to be accomplished, and to be accomplished in an effective way, efficient way, meaning less resources and a much greater result, outputs. And you need openness and some transparency. People need to follow the rule of law. We need to have some check in terms of ethical conduct. We want people to be competent and to have the capacity to do the work. We want also openness to change and adoption of new way of doing things. We want sustainability and long-term orientation. We want sound financial management. We want human rights to be respected. We need to have diversity in the organization. We need social cohesion, and we need accountability. So when we look at these principles, we can easily understand that they are difficult to achieve, and there have been real challenges for governments in developing countries, and the DRC Congo being one of them. When you read the literature, you can find reference to ways of measuring and way of ranking different countries in terms of how well they perform their responsibilities in terms of governance. And the World Bank has a methodology to do this kind of work. And Africa also, through the Moy Foundation, has also developed a way of measuring this governance ability in different countries. When we look at this and we try to compare, for example, Canada and Congo and South Africa on different dimensions that are reflective of governance, like voice and accountability, you can see very well on a scale of 0 to 100, you can see a country like Canada achieving score very high, like in the 90s, and South Africa being in the 70s or 60s. But the Democratic Republic of Congo has shown a ranking that is quite low, less than 20 on that scale in terms of voice and accountability. You can relate it to the election that took place in the Congo to get the people who are leading the different structures of the government. And this is reflected very well in what we see as a result here. Another dimension of governance is political stability and absence of violence and terrorism. This cannot be considered to be an area of good performance for a country that is known worldwide as experiencing a lot of difficulty. So what we are referring to here is a situation of poor governance exposing the country to the vigor of many poor achievements in the different areas, be it in the economy, be it in the transportation system, be it in the school system, be it in health in the healthcare field. So, having said all of this, we are coming to the consideration of this. We speak about governance, but we want to emphasize the fiduciary duties of the people operating in that capacity to do the job properly. And this is not what is happening. So we have some major interrogations. And this is being asked regarding the specific context of the DRC, which is a country where there is a civil war that has been going on for the last 25 years at least. And we are talking about a country where we don't just deal at this point with one single epidemic. We have 2, even 3 epidemics going on. But in this research, we were more interested in looking at the Ebola and COVID at the same time, that civil war. So we have some interrogation, and one major interrogation is this one. Has a structure of governance been set up to address civil war? This can be said to not be part of infectious disease, but it's part of health. When there is war going on, people are being killed, and people who are infected after being wounded in the war they cannot get proper medical attention to have their wound cleaned and so they can heal and move with their life. So we're asking also if any structure has been put in place, how effective has it been in ending the war or in minimizing war-related losses? More close to health, we can ask this question. As the structures been put in place and to work effectively in each of the outbreaks of infectious disease that we have mentioned, Ebola being one, measles being another one, and also now we are dealing with COVID. And we are looking at the time span of 45 years. And since the outbreak of the first Ebola epidemic in 1976. As the structure of governance, if any, discharge its duties in a transparent manner, as the structures of governance, if any, discharge its duties in a fair manner, as the structures of governance discharge its duties with accountability. So based on this question, we have developed some assumptions or research hypotheses. We are saying that yes, we can recognize that some governance has been shown in terms of ending the war, but it has not been fully successful. Every time that some initiative have been considered at a higher level to have a peace and able to take the time, like what took place in South Africa, in Sun City for many months of Congolese from different opposition parties, including the government, meeting to seek for how to resolve the war and have some peace. This does not lead really to the end of the war in the eastern part of the country, because some of the rebel groups did not want to be part of the negotiations. So whatever was decided there was applied to those who were there in attendance, but those who were not in attendance did not consider any resolutions to apply to them. We can also have as another hypothesis that we have various structures being put in place to address the outbreaks, but these structures have suffered due to the prevalence of wars and also to some practices which have made governance more difficult or not transparent, not accountable as it should be. So war have taught the ability of the leaders of the country to address outbreaks that have erupted in an effective way. There's not been transparent in the governance, because some of the wars have been even found to be planned and executed with the agreement or the involvement of the persons in a higher position of authority in the country. And no fairness has been really part of the game, and no accountability also. So what method have we used? Because we are saying that we have a problem, we want to demonstrate, to document and show that we have issues of governance. What we did is to use different approaches to try to understand what is taking place, because this is very important. We cannot say that we are confronting any infectious disease that is recognized as being an epidemic.
Hello.
So,
yeah, doctor, we have only 5 minutes more.
Okay.
Yeah, Dr. Bukara, we have only 5 minutes more to your presentation.
Thank you. So we put in place a team of people who are more familiar with the system and who could understand it, to have been exposed to things happening. They know the recent history. They know the history of the different outbreaks. And some of them, they are involved in different roles within the healthcare systems. They teach about it, and they are involved in running it or in playing a supervisory role. So we want also to do this by collecting and analyzing documents. So documentary techniques was used. And what we observed ourselves by being part of the system was part of our resources to learn. And in order to move forward with this technique, we asked some fund questions. So we went to appreciative inquiry. What has been done best in responding to COVID or to Ebola in the Democratic Republic of Congo? So to do that, we created a reading scheme, which we had a column for civil war, trying to understand its origin during what part of the history of the country it took place. And we had another column for Ebola, and we identified all the different outbreaks of Ebola. And for each of them, we asked a very tough question, asking ourselves, what was done wrong? What was done right? Can we be proud of something that was done in this context? And what is the literature telling us? What are the speeches made by the different stakeholders, Minister of Health, President of the country, and so forth? So that effort made it, was able to give to us much ammunition to come up with a table with a lot of information for each of these questions. So we were able to see that in the world, the DRC has been the only country to experience many episodes of Ebola. At this point, we are talking about the 11th outbreak that is going on after the 10th episode ended in August of last year. So this is a place where we can say it's a hotbed of outbreaks of infectious disease. And the question can come to mind, say, how can this be when we talked about surveillance involving many techniques to make sure that disease can be detected early and the people can be prevented from suffering and from dying? So to that question, we were not able to come up with a very satisfactory response, because there is something that is missing, and that making the epidemic to be there, to be coming back again and again when ways could be found to contain it and to make it. And the 10th outbreak was the most devastating. And it was very widespread, killing a lot of people too. In terms of COVID, so far we have, based on the record of this morning, we have 10,519 cases that were confirmed. And of those, 9,952 are said to be healed. And also only 271 cases of death. And at this point, we are talking about 296 people who are having the disease in a country of close to 85-90 million people. So we have been fortunate to some extent to realize that the fatality rate has not been as high as it has been seen in many places, in particular in the Western world. What has taken place in the country since the identification of the first case has helped to control the spread of the disease. The closing of airport, the control of local internal transportation system to make people to not move. And most of the cases happen in Kinshasa, and even in Kinshasa, in a particular areas, that was the concentration of these cases. And the president of the country came out with an emergency plan, which was widely approved by the different constituencies of the government. But we can say that in the process of doing these different things, there have been a challenge taking place. And this challenge is in terms of misinformation through social media. A lot of not truth being disseminated and making it for those running the riposte to be able to do their work properly. So we are able to identify many issues in terms of ethics and in terms of human rights violation. Let me point out one case of the Minister of Health was involved in a riposte against Ebola. As we are talking now, is spending his time in jail, 10 years, no, 5 years jail term for him. This was a decision made for embezzlement of money that was normally allocated for riposte against Ebola. And he misappropriated his fund, and he was arrested, tried, and found guilty and put in jail. And as we are talking now, there is the case for the current Minister of Health. I don't have all the details, but they, in the papers that we read in Kinshasa, there are reports that the Deputy Minister of Health reported his boss about embezzlement of money for COVID. And we have seen doctors and health personnel recruited to work in the report against COVID coming out and rioting because they have not been paid their salaries. So there are some issues of ethics, some issue of human rights. And a lot of killing has been done. War has killed more people than both outbreaks of Ebola and COVID. So war is a man killer, and it needs to be stopped. And we have not seen really major undertaking by the government to end wars in the Congo. And the last week, there were reports of people killed in Ituri area, the same area where the 10th epidemic of Ebola was reported and was experienced. There is a mistrust of the population. Yes, how many minutes are here?
Yes, it's time up. Just you can.
Okay,
yes, you can complete it within 1 minute.
Yes, this the things that we can mention regarding in terms of challenges that people are living in a context of fear. They don't trust the government. Even when the government, those who are intervening coming from outside, humanitarian organization, they don't even abide really by the rules that the government is setting. They will appear on the field and not trust health infrastructure that are in place in the community because they don't trust the people there. They think that they are not honest enough or they don't know enough. And this part of what they are saying can be true, but it remains that they are creating parallel system of providing services to those who need protection against epidemic or again to treat those who are suffering from this epidemic. And at the same time, the regular infrastructures are not utilized fully or given the support needed to do the job. So the role of the government is mostly like non-present, non-existent in the field, in particular in some part of the country in the East, where the humanitarian organizations have taken the role of providing some services, and they are doing so without aligning themselves neatly with what the government has been trying to do through the primary healthcare system of the country, which is a system made to have the local level reporting to the higher level, and then to the higher level, everything being coordinated in one single healthcare system. So that system is not trusted and is being bypassed to put in place another parallel way of providing services in the context of Ebola and in the context of COVID-19. I thank you very much for your attention, and I'll be happy to share a revised version of the PowerPoint I'm using here for those who are interested in learning more about governance in the context of the riposte against civil war, Ebola, and COVID in the Democratic Republic of Congo. Thank you very much.
Yeah, thank you very much, Doctor. Thank you for sharing your topic in front of this audience. So please kindly request you again to share your PPT so that we can forward to all the participants so that they can understand what the topic you have delivered.
Thank you very much.
Yes, thank you very much, Doctor. So now I welcome Dr. Ghazini Kharabi from Laboratory Medicine of Epidemiology, Pasteur Institute of Tunisia to give her presentation. Yeah, Dr. Ghazini, are you audible to hear my voice? Hello. Hello. Hello, Dr. Ghazini. Yes, thank you. It's fine. Hello. We are unable to hear your voice, Doctor. Just enlarge the PPT. Just
Hello.
hello. Yes.
Hello.
Yes, Doctor. We can.
I have a problem with my PC. I will talk in the PC of my colleague, Dr. Shrif.
Yes. Just you can share. Just you can share your presentation so that after completing your presentation, we will be sharing your PPT to all the participants. Just you can share your PowerPoint to or mention email ID or WhatsApp number So the after half an hour, we'll be inviting you again to join the event. You can deliver your talk, because it's just if you give the communication between this, there will be a problem. The alternate speaker cannot join the event.
قبل انت البرزنتاسيون تاعك قدم انت البرزنتاسيون حتى نبعث لك الاخبار.
ما عرفتش نقصد بلاصتك عشان نخدمها.
Meanwhile, shall we go with the alternate speaker?
Do you hear me?
Yes. Shall we go? Shall invite another speaker? Meanwhile, just you can write it.
So, can I present my poster while Dr. Kharoubi sent me his presentation?
Mm-hmm.
Okay, so I will share the screen. So I'm Ines Shrif. I'm an intern in public health in Tunisia, and I'm very pleased today to present the work called influenza vaccine uptake among Tunisian physicians during the 2018-2019 influenza season. So influenza is an acute respiratory infection that may cause severe illness. Healthcare workers' flu vaccination prevents influenza disease among both patients and caregivers. To the best of our knowledge, no national data on influenza vaccine uptake among Tunisian health professionals is available in Tunisia. We thus aimed in the study to assess influenza vaccine coverage during the 2018-2019 influenza season among Tunisian physicians, and to determine factors associated with influenza vaccine uptake during that season. So it's a cross-sectional study carried out in Tunisian primary and secondary healthcare facilities, including district and regional hospitals, during a period of 3 months from March to May 2019. Physicians with the direct patient contact, including which is defined as a face-to-face contact between a healthcare provider and a patient, including treatment, counseling, education, etc. These physicians were recruited according to a self-weighted multi-stage sampling. Data were collected through a face-to-face questionnaire containing questions on knowledge, attitudes, and practices regarding influenza vaccine. In order to assess factors associated with influenza vaccine received in the 2018-2019 influenza season, we used BVART analysis. So in this study, 167 physicians were included with a mean age of 38 years old, and majority were women. The sex ratio was 0.37. Among participants, 15.1% were vaccinated against influenza in the 2018-2019 influenza season. And in BVART analysis, we found that believe that flu vaccine should be mandatory to healthcare workers, high confidence towards influenza vaccine efficacy in preventing influenza among caregivers, believe that vaccinating healthcare workers may reduce work absenteeism, and a previous flu immunization in the 4 years preceding the 2018-2019 influenza season were significantly associated with a higher influenza vaccine uptake among Tunisian physicians in the 2018-2019 influenza season. So in conclusion, we found that less than 1/5 of Tunisian physicians were vaccinated against influenza in the 2018-2019 influenza season. We found also a higher vaccine uptake. That higher vaccine uptake was associated to a higher belief in vaccine efficacy in preventing influenza disease among caregivers, which highlights the need for periodic educational campaigns to raise physicians' awareness about influenza vaccine efficacy. And also the switch to an influenza vaccine mandatory policy should also be considered. Thank you for your attention. كيفاش نرجع؟ بس يروح من قبل نحكي نسمع بها حد. عشان من الكران يبينهم شو يسكتوا. Désactiver, arrêter. I finished my presentation. Do you hear me?
Yes, doctor. Thank you. Thank you for your presentation.
Thank you. Thank you very much.
Yes, I want to get a clarification. What about Dr. Gazin Karabi? The title is different apart from you.
Excuse me?
The title is different. Dr. Gazin. No. Yes, Dr. Gazina Karabi, influenza, vaccination acceptance and refusal reason among the Tanzanian elderly.
No, I presented my presentation. My presentation is influenza vaccine uptake among Tunisian physicians. I'm Ines Sharif, Dr. Ines Sharif.
Yes,
Dr. Khaloubi will present his presentation now.
Yes, ask her to get ready so that we can get. Yeah, that is the problem. Hello. Hello, Dr. Hennis. Hello.
Hello.
Yes, doctor. Just you can continue your presentation, doctor, instead of wasting time.
Continue the presentation with Dr. Khaloubi.
Yes.
Okay.
Hello?
Yes, we can.
I will present the presentation about influenza vaccination, acceptance and refusal reasons among Tunisian elderly. As you know, influenza vaccination is recommended for elderly persons, especially those with underlying conditions. In countries where influenza vaccination rates in elderly remain unsatisfactory, exploring attitudes of older persons toward flu vaccination could be useful to identify barriers and facilitator to influenza vaccination. The aim of our study was to determine the reasons for influenza vaccination acceptance or decline in Tunisian elderly. It was a cross-sectional study carried out in Tunisian primary and secondary healthcare facilities in the 2018-2019 influenza season among persons aged 16 years and over with chronic disease. Data were collected using a standard administered questionnaire. As a result of our study, 1,191 older persons were included. The uptake coverage was 19%. And the two main reasons that may lead to refusal of vaccination were the concerns that the vaccine could cause side effects. That was reported in 78%, and a belief that the vaccine was ineffective reported in 34%. As you see in figure 2, the reasons the ethical and moral reasons and religious reasons are minor, inferior to 1%, and the financial reasons and cost of vaccine is reported in 5% of cases. Concerning the main reason that may lead to accepting vaccination was doctor recommendation, receiving doctor recommendation, found in 40%. So, and when asked about the most trusted sources for information about influenza vaccination, doctors were reported in 91%, followed by pharmacists in 17%. As you see in figure 1, internet and media. Internet was not reported in any cases, and media only in 3% of cases as a trusted source of information about influenza vaccine. So our results highlighted the important role that doctors could play in promoting influenza vaccine among teenage elderly. Physicians should correct misconceptions about adverse events and efficiency of the vaccine. In fact, influenza vaccines are generally well tolerated and safe among older persons. Thank you. Thank you.
Yes, thank you. Thank you very much, doctor. Yeah, just to meanwhile, after completing your this session, just you can share your PPT because some are unable to add your voice as well as visible to your PPT.
Sorry, I don't hear.
Yes, yes. Just you can share your PPT so that we can share to all the participants. Yes, thank you very much, doctor.
Via email.
Yes, yes. So
okay. After the conference, I will share by email. We will share the posters.
Yes, yes. Next, we invite Dr. Manisha Mandal, MGM Medical College, MN Mandal University from India, to give presentation. Manisha Mandal. Hello. Yeah, I think Dr. Manisha Mandal is absent. So, next we invite Dr. Guru Prasad to give his presentation. Hello. Yes, sir. Dr. Guru Prasad.
Fine. Is this like
WhatsApp?
Is it my PPTs visible? Hello.
Yes, sir. Yes, sir.
My PPT is visible?
Yes, yes, sir.
Okay. Good evening from India and good morning, good afternoon from other parts of the world. I thank the organizers for inviting me to present my my work, which has been I'm continuously doing in past 3 to 4 years. These are the work which have been funded by the government of India the research work has been government funded. India is a continuous 2 projects which have been funded. I'm working on novel aspects of epigenetic mode of bacterial drug resistance. I'm the assistant professor working in Kamini Academy of Medical Science and Research Center, LB Nagar, Hyderabad. So before going into the details of my work, it has been already known that drug resistance in bacteria is playing a major impact on the health issues in world in hospitals, and antibacterial drug resistance till now was regarded as the antidote for the infections. So the discovery of antibiotics saved several million lives worldwide. Still it is saving, and antibiotic binding to the target interference or inhibits the essential cellular pathway of the bacteria. So to counter the effect of the action of antibiotics, bacteria has evolved several strategies to avoid the cytotoxic effects of antibiotics. For example, the major site of antibiotic action, as microbiologists, most of the people know, is mostly the ribosomal part, where most of the antibiotics will act and inhibits the protein synthesis, and mostly they target by a large and chemically diverse group of antibiotics. So antibiotic binding sites are clustered at a functional center of the ribosome, which includes the decoding center of the 30S ribosome. And as you all know, peptide transferase center, the GTPase center, as well as the peptide exit tunnels. Then how the bacteria will counter the action of these antibiotics? So this is the general concept of the action of different antibiotics, which prevents the protein synthesis. For example, the aminoglycosides, which block the initiation and translation, misleading to the mRNA. Tetracyclines block the attachment of the tRNA to the ribosomes. Streptogramins, which integrates with the distinct step of the protein synthesis. Macrolides prevent the continuation of the protein synthesis. Chloramphenicol, which are the common antibiotics, prevent the peptide bond from being formed. And lincosamides, which prevent the continuation of the protein synthesis. So these are the different antibiotics which play a role by killing the bacteria by inhibiting the protein synthesis. So there are different mechanisms of the bacteria to counter the action of antibiotics, such as the flux pumps, which pull out the antibiotics from the bacteria, and there are the inactivating enzymes, which will inactivate the you can say the antibiotical part, and the target modifications, as well as there are different mechanisms. So based on the ribosome, so in detail, we're going to talk about the methylation of the ribosome. Just we'll talk about the ribosomal structure. The bacterial ribosomal structure is 70S, you all know, it's again divided into 50S and the 30S. Again, the 50S is cleaved into 23 rRNA and the 5S rRNA, whereas 30S is 16S rRNA. So how prevention of antibiotics takes place? Nature has evolved an effective and elegant way of preventing the drug binding to the ribosome by simply addition of a methyl group to the rRNA. Till now, the mechanisms what we have seen, if you go back to the slide, this is a flex pump where they pull out the antibiotics, it throw out the antibiotics out of its cell, and there are the inactivating enzymes which will inactivate the antibiotics, and there is a alternative enzymes which will alter the pathway of the action of the antibiotics. So similar to that, there is one more mechanism we can say it is the prevention of binding by addition of a single methyl group at the rRNA region at the appropriate site, which will prevent the addition of antibiotics at the particular site. For example, the ribosomal RNA methyltransferase, this causes the antibiotic resistance, has been discovered 50 years ago. So there are different methyltransferase enzymes are produced, which leads to the binding of the addition of a methyl group at a particular region, which alters the structure of the protein, which prevents the binding of the antibiotics. For example, if you take the 30S and 70S ribosome, here the peptidal transferase center is there. Okay, the GTPase center of TRS and methyltransferase is there. So coming into the details, so first study which has been funded by SCRB and DST, Department of Science and Technology. It is the which have been awarded as a young scientist under young scientist scheme. It is the role of CFR gene in 23's rRNA methylation in drug resistance bacteria isolated from the hospitals and the ocular infections. What is the so coming to the drug resistance in gram-positive bacteria, what we see here, the newer antibiotics have been introduced to treat the multi-drug resistant microorganisms such as the oxazolidinone to prevent the action of MRSA, and the linezolid, which has been now routinely used mainly in the ICU patients where the high prevalence of MDR is known. That's the multi-drug resistance. The increased use of linezolid has been reported to treat the ocular infections such as the bacterial keratitis and endophthalmitis. So in this study, we have involved mainly the ocular bacteria isolated from the ocular infections, MRSA and vancomycin resistant gram-positive bacteria. So this is the table which shows the 23S different 23S ribosomal RNA methyl transferase, which leads to drug resistant antibiotic resistance in bacteria. For example, if you take the AVIRA gene, which is which methylates the nucleotide at the G2535 region, leads to resistance to avalomycin. So these are the different methyl transferase enzymes which will bind to 23S rRNA, leading to the development of different bacterial drug resistance. So recently, around 5 to 8 years back, gram-positive bacteria have shown resistance to linezolid, phenicols, lincosamides, pleuromethylanes, and streptogramin E. Such type of multi-drug resistant bacteria have been shortly called as FLOPS A. This type of drug resistance is known as a FLOPS. The resistance to these antibiotics has been reported in many countries like USA, Spain, Italy, and China. What is the importance of this drug resistance? Here, single addition of a methyl group has shown drug resistance to linezolid, different classes of antibiotics such as linezolid, phenicol, lincosamide, pleuromethylanes, and the streptogramin A. So the bacteria acquired the drug resistance simply by acquiring a single gene called the CFR gene. That is a chlorophenicol gene. What this gene will do, this will add a methyl group to the 23S rRNA, alters the structure at A2503. Sorry. Okay. So what happens here? The CFR gene, which encodes the methyl transferase, catalyzes the and initiates post-transcriptional methylation at the A2503. That is, a simple addition of a methyl group at this region will prevent the binding of all the different 5 classes of antibiotics. And this is first time acquired during the from veterinary Staphylococcus species from Staphylococcus aureus. So there is a positive information, the presence of this bacteria, mostly conferring mutations in most of the countries, including India. As India is known to be a hub of the multi-drug resistance, the present study was designed to screen the bacterial isolates derived from ocular and the ICU infections obtained from healthcare facilities in and around the city where I stay, that is Hyderabad. The aim of the study is to investigate the presence of CFR gene, which confers resistance to 5 different classes of antibiotics already I mentioned, as well as there is a mutation of V domain of 23S rRNA, which also confirms the drug resistance to linezolid. So we don't know whether the linezolid resistance is due to the presence of CFR gene or due to the V domain mutation. So we screen both the mutations as well as for the presence of CFR gene. As I told you, a total of 308 bacterial isolates are obtained and study has been done 2 years back. And this is the whole bacteria where we have screened. These are different ocular specimens we have selected, like anterior chamber tap, aspirates, conjunctival swabs, pus, exsantated tissue, lens fluid. These are the different specimens from which we isolated these bacteria, which mainly include Acinetobacter, Enterococci, Klebsiella, Micro, Pseudomonas, Staphylococcus. The bacterial isolates are subjected to routine Kibri-Bias antibiotic sensitivity test. E-test has been performed wherever we found there is a linezolid, clindamycin, daptomycin, and pristinomycin resistance, and they are interpreted by CLSI guidelines. So this is the routine DNA extraction what I have done. This is the PCR parameters, and this is the primers for the CFR gene screening, as well as for the screening for the mutations. What we found here, detection of CFR gene. The CFR gene has been found in a Staphylococcus aureus isolated from the septicemic patient admitted in ICU, as well as the presence of Staphylococcus epidermidis has been seen, as well as a CFR gene has been found in Staphylococcus epidermis from the corneal ulcer patient. Both these patients were treated with the linezolid antibiotic. So along with the presence of CFR gene, we also found the V domain mutations. This picture shows the presence of V domain mutations of 628 base pairs along with the samples without the mutations. So what is the highlight of this study? Our finding of CFR gene in Staphylococcus aureus is of clinical significance, as linezolid is only approved drug to treat the methicillin-resistant Staphylococcus aureus as well as the vancomycin-resistant enterococci. Our study is first time highlighting the importance of screening for CFR gene in multi-drug resistant gram-positive bacteria. And we published this paper recently in one of the reputed journals. So based upon the experience what we got on gram-positive bacteria, we thought whether the similar aspects have been seen in the gram-negative bacteria. So when we submitted this part of the project to the Department of Science and Technology, they readily agreed and approved this project for the funding. So what is the present study? It is the role of 16S rRNA methylase in the development of bacterial drug resistance, mainly in the gram-negative bacteria. So what is the 16S rRNA? This is similar to aspect where we have seen the 23S rRNA methylation in gram-positive bacteria. Methylation of 16S rRNA has been recently emerged as the mechanism of resistance against the common antibiotic which regularly used as to aminoglycosides. This event is mediated by newly recognized group of 16S rRNA methylase. These responsible genes are mostly located in transposons within transferable plasmids, which is very, very important, which provides them with the potential to spread horizontally from one bacteria to another bacteria. So where the 16S rRNA methyl transferase acts, transcriptional methylation of either the N7 position of the nucleotide at G1405 region or N1 position of nucleotide at A1408 position. So these are the two positions at which the 16S rRNA methylation acts and prevents the binding of aminoglycosides. So this is a three-dimensional structure of A site of 16S rRNA bound to the gentamicin. As I already told you, the methylation might act here or at 1408 or 1405 region and prevents the binding of the gentamicin. So whether the studies have been happened? Yes, it's happened in worldwide. High prevalence of plasmid-mediated 16S rRNA methylase gene has been found in Chinese studies, and emergence of ARM-A. What is ARM-A and RMTB are the genes which are involved, are the 16S rRNA methyltransferase genes, which confirm resistance to 16S rRNA in Belgium. The study has been done in Belgium. And one more study, 16S rRNA is highly resistant, amikacin resistant in Klebsiella pneumonia patients in the Korean region. So what are the objectives of this study? We will try to evaluate the presence of these 4 genes, which are known as 16S rRNA methyltransferase genes mainly in the gram-negative bacterial isolates. Okay, and the evaluation of methylation state of 16S rRNA. This is ongoing study, still study is going on the RNA bisulfite sequencing to evaluate the presence of these methyltransferase genes. So this is the overall specimens what we have collected from different body fluids, and around 200 isolates have been screened, and 150 cases are resistant to the gentamicin and amikacin. As I told you, around 60% of these organisms, gram-negative bacteria, have been shown to be resistant to aminoglycosides. So DNA extraction has been done, and the PCR primer. These are the different primer sequences what we have selected for screening of different ARM-A, RMTA, B, C, and D. What is the mean age of the patients? The mean age of patients is 50.7. Aminoglycoside resistance has been seen in around 60% of cases, and several 16S rRNA methyltransferase genes have been detected. So this is the results which you will be showing amplification of different genes like 774 base pair region of the arm A, and this second picture shows the presence of RMTB. Several genes have been detected in the course of screening of 16S rRNA methylase in different gram-negative bacteria. What is the distribution of 16S rRNA methylase genes in aminoglycoside resistant bacteria in our study? So these are the percentage of different genes we have isolated, and these are the different bacteria. Klebsiella acinetobacter, E. coli, Pseudomonas. We found a high expression of ARMA compared to that of other methyltransferase genes. This is the representative picture of the methylase genes. So what is the reason? So there is a concept that along with the 16S rRNA methyltransferase genes, there is a co-expression of other mechanisms which leading to a development of higher drug resistance. Diverse carbapenem resistance have been found in 16S rRNA methyltransferase producing bacteria. Those bacteria which are resistant to aminoglycosides are also known to be resistant to beta-lactamase as well as the carbapenems. So along with the screening of 16S rRNA methyltransferase, we thought of screening the presence of carbapenemase genes in these multi-drug resistant bacteria. So detection of multi-drug resistant bacteria helps to reduce the dissemination rate. So what is the results? We have screened the presence of OXA-A, WIM, and KPC, which are the genes which are known to cause the carbapenem resistance in gram-negative bacteria. So there are different genes we screened. Expression of carbapenemase genes in 16S rRNA methylase positive genes. In 11 cases, we found the co-expression of both genes in gram-negative bacteria, and high co-expression of genes has been noticed in RMTD of 16S and OXA48. So this is the distribution pattern of a total number of organisms which isolated, and these are the high expression of both 16S rRNA methyltransferase genes as well as the carbapenem genes. So there is a combined expression of 16S rRNA methyltransferase genes as well as the carbapenem genes in multi-drug resistant bacteria. So these are the different bacteria which have been isolated and which have been screened, and we found the presence of both genes. See, RMTB and RMTD represents the methyltransferase 16S methyltransferase genes. OXA represents the carbapenem genes. So what's coming to the discussion? The study from worldwide shows the existence of 16S rRNA methyltransferase genes. We also shown the presence of these genes, and these are widely distributed in UTI infections. Our results coincide with and provide evidence of widespread 16S RNA methyltransferase genes. As I told you, and we successfully demonstrated the presence of multi-drug resistant genes in a single bacteria. Coexistence of multi-drug resistant mechanisms, including methyltransferase and ESBL, has been shown in northeastern Indian studies, and emphasizing our study importance coexistence of different MDR mechanisms, multi-drug mechanisms. So it will reduce the incidence of treatment failures, as well as what is the use of this screening of these genes? It will reduce the incidence of treatment failures because presence of aminoglycoside resistant bacteria. So the physician might avoid the use of aminoglycosides. So several detection mechanisms are still going on. Innovations are going on for early detection, such as aminoglycoside resistance detection media. As I told you, we published several publications along with the mainly on the aspects of epigenetic mode of bacterial drug resistance. Previously, we published on 23S rRNA. Then we published a review article, which is published in peer review journal like British Biomedical Bulletin by epigenetic mode of bacterial drug resistance. And recently, with the co-production of 16S RNA and methyltransferase carbapenemase in multi-drug resistance has been accepted in a peer review journal, Journal of Clinical and Diagnostic Research 2020. So based on this epigenetic mode of drug resistance, I have been invited in renowned conferences such as World Congress on Infectious Diseases and Antibiotics, which was held in Indian Institute of Science in Bangalore, as well as recent World Congress of Infectious Diseases along with the present conference. So I have to acknowledge for this, I have to acknowledge my guide, my PhD guide, Dr. Geeta K. Vemuganti, who is a well-renowned scientist. He has been received a Bioscience Award, as well as two of my co-guides like Santosh Honavar, who has been awarded Shanti Swarup Bhatnagar Award, which is also known as the Nobel Prize of India, as well as Dr. Javed Ali, who has been awarded Shanti Swarup Bhatnagar Award. And not to forget the persons who are working behind this wonderful work, my students, Mr. Ravi Kumar and Mr. Sandeep Kumar Tipparthi. They have done the whole lot of hard work, as well as I have to acknowledge Department of Microbiology, Kamaneni, for providing the base, as well as the funding agencies, SCRB DST, for providing the fund to carry out the research work. So several persons are there who contributed in doing to carry out the research work. And recently I have been awarded the Best Researcher Award. Thank you very much.
Thank you. Thank you very much, sir. Any questions? Any questions to Dr. Guru Prasad? Yeah. Thank you. Thank you very much, Doctor.
Thank you. Thank you.
For giving you. We handed your speech. We are all pleased to with your topic. We are fresh your speech. Thanks again. Looking forward to meet you next time.
Yeah, thank you very much. Thank you very much for inviting me. Thank you.
Yeah, thank you very much, Doctor. So now we rejoin again Dr. Shampandal Mandal. As we are disconnected.
Yes, I like to rejoin.
Yes, yes, sir.
Yes.
Yes, sir.
That display, previous display to be removed.
Yes.
Previous display.
Yes, yes. It was removed, sir.
Yes.
Angaline.
Please. Hello. Is it visible?
Yes, sir. Just you can proceed. Just you can upload your PPT, sir.
Okay. My screen is visible, sir.
No, sir.
Oh, 1 minute. What happened? Sir, screen is not visible. Hello?
No, sir.
Is it now visible?
Yes.
Hello?
Yes, yes, sir.
Yes, yes, please.
Yes, it's going to start.
I want to back to my previous slides. Actually, I had completed 1 hour, more than 1 hour, but without connection. I did not understand, and that's why very sorry. And to start it again. Hello?
Yes, yes, sir.
Yes.
Hello.
Yes, I have completed this one.
Yes, sir.
This one also.
Yes, sir.
Hello?
Yes, yes, sir.
Yes, sir. This is completed.
Not 1 minute, just it is working. It is completed, no, sir. So,
yes, sir.
This is after introduction. I have background. This is my actual part of the speech. First, we have to isolate the probiotic bacteria from different types of sources, which is stool sample and card sample. We have isolated various types of lactic acid bacteria with the utilization of MRS agar media and MRS broth. First, we have inoculated such samples to MRS broth and then broth culture after 37 degrees Celsius 24 hours. We have streaked repeatedly on MRS agar plate to get single colony, which are showing here, and we then followed tested TSI whether to see it is utilized or not, the glucose, lactose, and sucrose. And catalase test, oxidative test, and indoor test have been done. And when we see that on lactose MRS media, these bacteria were gram-positive rod and oxidase and catalase negative, and these are indoor negative. So these are here, and the genus is Lactobacillus. But at species level, we have followed 3 tests: carbohydrate, biochemical test, and 16S RNA gene sequencing. We in the carbohydrate panel we have utilized by the bacteria and different biochemical tests. And finally, we have sequenced. We have sent our sample to the Promas Biotech Limited India for sequencing, and after sequencing we blast the sequence with other sequence present in the gene bank of NCBI, and that's why we have identified the species level. And 11 bacteria we have from our 45 strands we have identified in this way by blast method 11 strands from different sources, which are isolated from different types of cards and human stool sample. So these all about the isolation and identity. And this is phylogenetic tree of one strain we have isolated, that is Lactobacillus fermentum LMEM 10 strain. We have meshed in the NCBI blast system and found that this is Lactobacillus fermentum. And similarly, we have identified Lactobacillus plantarum from card sample and another strain from card sample. Not working. And this is another strain. This is Lactobacillus fermentum LMEM 22. Similarly, we have prepared the phylogenetic tree, and many other isolates we have did in this way, but not displayed here because of time constraints. And this is all about identity of the probiotic bacteria isolated from different sources. Now, to be characterized probiotic attributes of lactobacilli in our sample. So what we have to do? First, we have to see whether these are probiotics or not. We have tested in different way to test sodium chloride tolerance at different length, because we know the lactic acid bacteria thrive in different environmental conditions, which is inside the human host, in the intestine, as well as externally in different environmental niches. So different osmotic pressures may be created to the bacteria, but they can tolerate high level of tolerance and low level of tolerance also. So they can compete with that situation of environmental condition with sodium chloride concentration. And we know bile secretion occurs in our intestine from liver, and as a result a hostile environment is created in the intestine, and in this system the pathogenic bacteria cannot thrive or cannot live or cannot colonize in the intestine wall, but lactic acid bacteria can colonize because they can tolerate bile salt and also low pH. We know our stomach secret ACL, that means hydrochloric acid, causing the system inside the stomach low pH near about 4. When we consume lactic acid bacteria as probiotic with different vehicles such as food, fermented food, or in pouch, medically obtained medical probiotic, then the bacteria passes through stomach. Actually they face ACL condition, low pH condition, and then thereafter reach the intestinal lumen, so that they can colonize in that system, in the intestinal system, on the intestinal wall, to exert physiological function, health benefit to the host, as well as they show resistance to high grade of temperature, very high range of temperature starting from 40 degrees Celsius to 80 degrees Celsius, because they thrive in different environmental situations where different temperatures, varied temperatures are seen. So these all about in vitro system, the probiotic features of lactic acid bacteria, and thereafter we have to consider the pathogenicity testing, because we have completed the probiotic criteria, now the pathogenicity testing. So we have to see the non-hemolytic pattern of the bacteria. How it is tested? We have utilized blood agar media, and we stick the strain and see the hemolytic pattern, and this should not be hemolytic, as well as this must be DNase negative and gelatinase negative, and they must be sensitive to antibiotic resistant, not sensitive, but if resistant, this should be intrinsically resistant. That means gene modification in the chromosome, but not in the plasmid, because plasmid is transferable and they may be transferred from good lactic acid bacteria to bad bacteria which are pathogenic, that may be gram positive and gram negative. How we have determined the test? See this. Different panels have been utilized. In the first panel, L. casei and another strain L. fermentum is there. They showed tolerance to different range of sodium chloride and low pH 2 to 4 and bile salt 0.2 and 0.3. And another panel series for lactic acid bacteria to be utilized a probiotic, shows a high range of sodium chloride concentration, low pH and bile salt 0.3.
Hello.
Hello.
Yeah, doctor, we are unable to hear your voice.
Hello again. This was disconnected.
Yes.
Yes, sir. 1 minute. 1 minute. 1 minute. 1 minute.
Wait.
One minute, sir. I am joining.
Yes, no problem, sir.
Is it visual, sir?
Yes, sir. Just.
Hello.
Yes, sir.
Sir, is it visual?
Yes, sir.
Yes, sir. Then I am displaying again. So different panels, these I have already discussed, and these are different types of bacteria, lactic acid bacteria isolated from different samples. These are from the card, homemade card, and this is from commercially available card, and this is from infantile stool. And thereafter, we have seen that these criteria are made for the strains, that is, they are resistant to 6.5 degrees Celsius sodium chloride and bile salt 1.125 to 0.5 and low pH 2 to 4 and temperature 15 degrees Celsius to 42 degrees Celsius. And then this is lysozyme. We know in our saliva in mouth cavity when saliva secreted, lysozyme is liberated, and this lysozyme act on pathogenic bacteria and destroy their growth. But the probiotic bacteria remain alive because these are resistant to 5 to 10 milligram per ml or more in some cases or for some strain. So these are the lysozyme tolerant, and these are hemolytic. See this, these are gamma hemolytic. That means this is non-hemolytic. These are gelatinase negative. These are DNase negative. So these are non-pathogenic. So how to describe this? See this. We have utilized blood agar plate. We have strict different types of bacteria. And this is control strain, non-pathogenic strain, Staphylococcus aureus, and these three are Lactobacillus fermentum to be utilized as probiotic. These are all strict on the blood agar plate. And we have seen that in this case, see this around the colony after their growth on 24-hour incubation at 37 degrees Celsius, around each colony hollow clear zone is found because these bacteria utilized hemoglobin of RBC, and they just causes destruction of tissue. But in these cases, there is no zone. When such clear zones are found, these are known as beta hemolysis caused by pathogenic bacteria. And another kind of hemolysis occurs, which is in which greenish zone beside a clear zone is obtained, and this is alpha hemolysis. But in case of L. fermentum, no such kind of zone, either greenish or clear zone are formed. So small colonies are formed. So these are non-hemolytic and also regarded as gamma hemolytic. Also, such bacteria where DNA is negative, because see this, so you utilize toluidine DNA agar media. Here DNA is present, and this is a pathogenic bacteria control strain as aureus. This is capable of producing DNAs. That means the DNA produced act on DNA and degrade DNA. That's why when we applied in ACL, what you will see, around his colony, clear zone, white zone were obtained. But in case of L. plantarum lactobacillus strain, no such activity were seen. Another characterization is gelatin liquefaction. When it is lactobacillus probiotic, it is not capable of causing liquefaction of gelatin because of lack of gelatinase in nutrient gelatin media. Whether in P. vulgaris, this is positive because this can secrete gelatinase enzyme and cause gelatin liquefaction. This is a pathogenic bacteria. So this is all about the pathogenicity testing. That means the probiotic features are studied as well as their non-pathogenic testing has been tested. Also, we know a good probiotic bacteria must be antibiotic sensitive, and if it is resistant, that must not be transferable. That means that can be located in the gene of chromosome, not in plasmid. Plasmid is transferable. So here we have tested antibiotic susceptibility testing utilizing MRS Diemer Rogosa sarcomedia, on which we have swabbed, inoculated the L. fermentum strain, and thereafter we placed disc and incubated 24 hours and measure the zone of inhibition. And we have seen that when the range is less than 15 or equal to, then these are resistant. When in between 16 and 20, the zone of inhibition, these are intermediately susceptible. And when it is 21 millimeter, then these are susceptible. So we are seeing that the bacteria, lactic acid bacteria to be utilized as probiotics, shows mostly sensitivity to the antibiotics, but this is gentamicin and then this is vancomycin, but these are non-transferable and located in the gene of chromosome. And when we consider MIC, by this testing minimum inhibitory concentration value, they were also within the range of sensitivity, and very few were sensitive, such as ciprofloxacin, gentamicin, and these we know these are non-transferable. And another strain, Lactobacillus fermentum LM-EM22, these strains were also sensitive to the antibiotics, but to which these were resistant ciprofloxacin, kanamycin, methicillin, vancomycin. These were resistant, but they cannot transfer from good probiotic bacteria to bad pathogenic bacteria, gram-negative or gram-positive. So we have just now see the antagonistic property of lactobacilli, because the probiotic lactobacilli must have produce lactic acid and hydrogen peroxide, as well as low molecular weight protein bacteriosin. These all have antibacterial activity, and these are produced by lactic acid bacteria. We have in the panel utilized indicator bacteria, both gram-positive. These are the gram-positive bacteria for our test, and these are the gram-negative bacteria for our test. And for pathogenic bacteria, we have tested antibiotic susceptibility testing. We utilize 16 antibiotics, and you see that the bacteria show different pattern of antibiotic resistance, 3 or more. When a bacterium is resistant to 3 or more drugs, then these are multi-drug resistant. So our all bacteria utilized in this test are multi-drug resistance. And this is the Proteus vulgaris, shows resistance to 11 drugs and 10 drugs, Klebsiella pneumoniae, Pseudomonas aeruginosa, other shows more drug resistance. And thereafter we have calculated multiple antibiotic resistance index. So what is this? The number of resistance. Suppose this bacteria were tested against 16 antibiotic, and shows resistance to 6 antibiotics. So when we divide 6 by 16, then this value we obtain. This is the MR index. When MR index is more than 0.2, then it is derived from a place where the pollution has been acquired with antibiotics. And when the value is ranged up to 0.4, then it is animal fecally polluted. And when it is more than 0.4, then the bacteria may be originated from human fecally polluted area. Now we have tested antibacterial activity of lactic acid bacteria. We have utilized two different tests. Agar overlay method, on which we utilized the MRS agar plate and the spot inoculated. These are the lactic acid bacteria. We have inoculated by spot method and then allowed to grow for overnight to 48 hours. And when spot growth were seen, then what we have done, we have taken melt agar, Muller-Hinton agar or nutrient agar in a test tube and mixed with the pathogenic bacteria, these bacteria, and then overlaid on it, and thereafter solidified and dried and incubated. And after overnight incubation at 37 degrees Celsius, due to the action of spot inoculated lactic acid bacteria, they inhibit the growth of pathogenic bacteria spread over it, and that's why zone of emission was rotated. See this, due to the high capacity of antibacterial activity, all bacteria were produced a large size zone, which are represented in this table. I am not taking time much because I have already discussed for 1 hour, more than 1 hour, but non-effectively. We have also utilized another test beside agar overlay method. This is agar well diffusion method, in which system we have swabbed on the nutrient agar plate or Muller-Hinton agar plate, swabbed with the bacteria which are pathogenic, clinical bacteria which are utilized in indicator bacteria. And after scooping well, we taken the culture filtrate of lactic acid bacteria and put into the well and allow to dry and then incubated for overnight. And we have seen also in this method the zone of inhibition. And from this method, we have calculated bacteriocin activity, and from previous method, that is agar overlay method, we have calculated R, which is the entire diameter of zone of inhibition minus the diameter of spot probiotic and divided by 2. This is R. And when the R value remains in between 2 to 5, then the activity is low. When this is less than 2, this activity is very less or absent, and when the value is greater than 6, the activity is high. And similarly, we have calculated the bacteriocin activity in the form of arbitrary unit per ml. What is this? We have measured the zone of inhibition in this system, and it divides by the volume taken into the 50 to 100 microliter cell-free culture have been taken and multiplied with 1000, and the value were obtained. These all systems have been depicted in the table series. The zone diameter of inhibition, and here R value, the definition have already given by R or clear zone. These are the values. So we have seen that these are weak to inhibit the growth of such indicator bacteria, Acinetobacter baumannii, E. coli, P. vulgaris, and Salmonella typhi. And see this, all the R value of higher size. So other 3 bacteria are very excellent to cause the inhibition of such pathogenic bacteria represented here. In the similar way, from agar well diffusion method, we calculated a arbitrary unit, that means bactericidal activity, bacteriocin activity, and when the value is 200 or more, then these are excellent. See this table, we have calculated thereafter after all testing cumulative probiotic property. What is this? Observed score by maximum score into 100. What is observed score? We have utilized 5 different criteria already discussed: acid tolerance, wild salt tolerance, antagonistic activity, antibiotic sensitivity, hemolytic activity. When non-hemolytic, that means gamma-hemolytic, this is 1. When sensitive to acid and bile, this is 1. And when resistant to acid and bile, then it is 1. And antagonistic, when in the midway, that means intermediate, then it is 0.5. But when the value I have already told, when it is the value is more than 200, then this is 1. So when a criteria sum up for this bacteria, we have seen that the score is 4, and other for other is 5. And we have multiplied 100, then it is 80%. 100% for other strains, we have the calculated CPP. So CPP criteria is a very good criteria to be estimated as a local isolate of lactobacilli to be utilized as a probiotic. So now the bacteriocin activity, we have seen that the lactic acid bacteria itself can cause the inhibition of growth of pathogenic bacteria. And we know that bacteriocin is a potential substance, low molecular weight, and these are antibacterial. And we first isolated from our lactic acid bacteria to be utilized in probiotic, and utilized the method ammonium sulfate. So actually, in the culture, cell-free culture, we have added ammonium sulfate, and precipitation were done after overnight incubation in 4 degrees Celsius, and thereafter a pellet has been formed after centrifugation, and after this pellet we have washed with distilled water, and thereafter finally we got the pellet of the bacteriocin and dissolved with phosphate buffer solution, and thereafter we tested it against.
Hello, sir. Excuse me, sir. The more 5 minutes. Hello.
Resistant pathogenic bacteria as well.
Hello. Yeah, Doctor Mandel, we are unable to hear your voice again. We are facing same problem. Hello. Hello. Sir, we are getting the same problem again from your side. We are unable to hear your voice. Mm-hmm. Mm-hmm. Hello. Sir, we are getting the same problem from your side, sir. Hello. So meanwhile, we'll go with alternate speakers, sir. Just you can ready, because we are unable to hear your voice. So next speaker is Dr. Manisha Mandal from MGM Mandal College, MN Mandal University from India. Hello. Hello. Hello.
Dr. Shamapada will start now. Will you start now?
Sir. Hello.
This already have covered, and this is
sir, just more 5 minutes more, sir. Just
proteinaceous nature of vectorsin, and this is damaged by protein HK trypsin, but not to amylase. The amylase is causing damage to or hydrolysis of carbohydrate. And what we have seen that in case of E. coli, Baumannii, and Escherichia cytogenesis, actually the zone size were higher, and when treated with trypsin, the zone size reduced significantly, but when we treated the vectorsin with alpha amylase, and both zone size were decreased but not significantly. That means we can say the vectorsin are proteinaceous in nature. These are now we will test in combination, lab combination, that lactobacilli in combination with lactobacilli, and these are the lactic acid bacteria and their resistance pattern that we have already discussed, and the single use of lactic acid bacteria in spot culture, and the zone of inhibition are noted, and when you utilize in combination the 2S3 strain and DC16 strain, their zone sizes are increased, and when in approximation test, the zone characteristic pattern of zone inhibition are noticed. These structures indicated they are synergistic in nature. We have calculated growth inhibitory index. What is this? We have measured the single action of antibacterial activity and added, and the combined action of antibacterial in terms of zone diameter inhibition, and combined activity was divided by total of single action of both, and this value are obtained. When the value is 0.5 or more, it is excellent, and it is synergistic. We have already discussed, and when you see that the strain is S3 and DC3, they both are synergistic.
Excuse me, sir. Excuse me, sir.
L2B, these were against synergistic against E. coli, but not K. immunity. In
Yeah, doctor. Hello, sir.
Hello.
We have only 5 minutes more, sir.
Yes.
Just you can come.
Yes. These are in combination of bacteriocin and we have isolated the plasmid DNA and see that these are not plasmid mediated. These are mediated by chromosomally linked gene, and see this after curing, the plasmid bands are removed. In case of 3 strands, 1 band removed, and in case of this strand, 2 bands are removed. But their property of antibacterial activity and the resistance patterns are remain same. That means these are now linked to plasmids. This table indicates that the zone sizes are same when we tested in kanamycin, methicillin, and vancomycin, and the antibacterial activity remains same. So these are not plasmid linked; these are linked to another gene located in chromosome. And these are single action of antibacterial activity, and there are values, and these are by agar-oil encryption method for these bacteria, lactic acid bacteria. So we have utilized such bacteria singly, and then we have measured the amount of bacteriocin from different types of lactic acid bacteria that range from, in this way, the highest amount 2.8 and 2.9 for LMEM15 and LMEM2. Both are, one is plantarum and one is fermentum isolated from card samples. So before going to show the combined action, we have tested the antibiotic against bacteria to for single action, as well as lactic acid bacterial bacteriocin against same. Hello.
Yes, sir.
Yes.
Hello, sir.
Yes.
Single action. We have seen that in single action the bacteria were worked in this way, and when we have determined their MIC value, the values are represented in this table. And in combination, lactic acid bacterial bacteriocin with different kinds of bacteria, the zone size are increased. These are for gram-negative bacteria, and these are for gram-positive bacteria. But in this color 6, the zone size are not increased. And thereafter, we have calculated GII, which we have already discussed. When GII value is higher than the synergistic activity or noticed, but in these colors point below 0.5, these are non-synergistic, even they may show not antagonistic. So combination is not good, but when it is more than 0.5, then it is good. That means synergistic. In the similar way, we have tested MIC as well as FIC for combination test. FIC is fractional inhibitor concentration of such antibiotic and bactericide amount. The amount of MIC can be defined the amount lowest concentration of antibiotic or bactericide that can kill or destroy the growth of bacteria, bacteria. And this is the lowest combination of bactericide and antibiotic to cause inhibition of growth. And when the value is less than 0.5, all the cases, in all cases, the value is 0.5, and therefore we have seen that the synergistic activity were noticed, and for LMEM 15, the synergistic activity were also noticed. This is all about our probiotic features, antibacterial activity, and toxicity. But we know probiotics, for probiotics growth, we already have discussed prebiotics are required, and prebiotics display different kinds of roles. So, and thereafter physiology of lactic acid bacterial probiotics and maintain. And when the physiological property of lactic acid bacteria maintain, and then we get the health benefit.
Sir, it's time up. Sir, excuse me, sir, it's time up.
Here, and there may be concern regarding the cause of disease in some situation, but not in normal individual. In immunologically compromised individuals, bacteremia, pneumonia, abscess, and endocarditis may be caused. So we have to test well before utilization of lactic acid bacteria to be used as probiotic. And thus we have seen that our isolates are good probiotics. The probiotics may be isolated from locally available cut sample or human stool sample, in particular from infant sample. These are good antibacterial agent. They both combination exert synergistic result. They are bactericide also antibacterial, and in combination with antibiotic, they show synergistic activity, and so the bactericides are antibacterial, and research can be continued to get good bactericide and good probiotics in order to combat the bacterial multiple drug resistance as well as the infection caused by them. So these are the publication in brief on the field with probiotics, and ultimately, thank you, and we acknowledge Science and Technology, Department of Science and Technology, India, and the student who was related to this work. There was his other got PhD degree with this work. Thank you. Thank you giving me chance again. Thank you.
Thank you. Thank you very much, sir. Any questions to Dr. Mandel? Any questions from the participants? Okay. We thank you for your stimulating speech, sir. Thank you very much. We are very pleased with your topic.
I am stopping, and then
yes, sir. We appreciate your speech.
Another.
Yes, thank you very much, sir.
Yes.
So we welcome Dr. Manisha Mandal from MGM Medical College, MN Mandal University from India.
Okay.
Hey, Dr. Manisha Mandal, please go ahead with your presentation. Hello. Yeah, Doctor. Yeah, Dr. Manisha Mandal, we are unable to hear your voice. Please go ahead with the presentation.
Yes, sir. She'll join in shortly.
So kindly upload your PPT, sir. Hello.
Please allow her. She is not allowed to join. She is not allowed to join from your side.
Oh.
হ্যালো স্যার, আপনারটা স্টপ শেয়ারিং করেন না স্যার, মনে হয়।
Hello. So, may I know your name, sir? Name, madam. We can unable to see you on the screen.
Yes, sir. Madam, join shortly.
Okay, just. Just ask madam to join. Just.
Yes, sir. Madam, join shortly. She is trying to join.
So, meanwhile, shall we go with alternate speaker? All right. Hello. Excuse me, sir. Meanwhile, we can go with alternate speaker. Ah, yes, it's no problem. Thank you. Yeah, Professor. Okay, sir. Thank you. Professor Madhuke is going to join the event.
Hello, can you hear me now?
Yes, sir. Yes, sir.
Okay.
You can enlarge your.
Thank you. You can hear me? Okay. Ladies and gentlemen, you are welcome. The title of the lecture is HIV infection reduction rates in treated patients as model for predicting outcome of clinical trial of the drug we call antivirus on COVID-19. The common thing about HIV and the COVID-19 virus is that two of them are RNA viruses. And being RNA viruses means that they are all positively charged. Every virus has electrical charge. The RNA viruses have positive charges. So if we can design a medicine that will attack the charges, we may be able to use HIV as a model to study outcome of the treatment on COVID-19. So starting with the reasons terminating viral infections is difficult, and we make suggestions what we can do to overcome the difficulty. The news we are getting that some patients, some survivors of COVID-19 have already become reinfected, suggests that immunity from the COVID-19 virus does not last for a long time. That means that the search for vaccine may not be solution to the pandemic, because immunity from human vaccines are required to last at least for life, or at least for 10 years. If it's short, it may not be protective enough. Therefore, need for us to search for treatment, medicines that can cut the transmission chain. If we're able to cut the transmission chain, we may eventually eradicate the pandemic. For their small sizes, that is to say 5 nanometers and above, viruses are able to infect cells that are inaccessible to medicine because of their large molecules. Those inaccessible cells are the so-called viral reservoirs of or sanctuary cells, which makes HIV look mysterious. People say, how can you cure HIV? What of the sanctuary cells? There are something like sanctuary cells, only that those are cells that medicines cannot reach. Therefore, for this reason, though some conventional medicines do not cure HIV/AIDS because HIV causes a severe immune deficiency, but COVID-19 is not associated with immune deficiency. For that reason, if you use physical medicines that work physically to treat HIV, those medicines are not able to reach infected cells, and there's no immunity to complement them. But such medicines can work against COVID-19 because COVID-19 does not cause severe immune deficiency. There are still immunity remaining in COVID-19 patients to complement medicines. For that reason, some conventional medicines that do not work against HIV have been found effective in COVID-19. Also, HIV is a chronic disease requiring prolonged treatment, while COVID-19 has short course. Patients either die or recover within days. So which means that even if you are using methods that work by inhibiting biochemistry of viruses, their side effects will not be so much in COVID-19 because the treatment doesn't last for too long. Whereas if it was HIV, such medicines cannot be continued because of their severe side effects. Prolonged treatment with medicines which inhibit biochemistry of viruses is associated with the intolerable side effects. I have said it because of similarity between viral biochemistry and biochemistry of normal cells. These are reasons why HIV has remained incurable for over 3 decades, almost 4 decades now. Whereas COVID-19 that has not lasted for up to a year, millions have already recovered. That is the difference. So whatever medicine, if we're able to design medicine that can inhibit HIV and cure HIV/AIDS, that means that medicine will be very, very effective against COVID-19. That is why we are using HIV as a model to study COVID-19. Antiviral medicines should therefore act physically on features that are specific to viruses that normal cells do not have. Instead of acting against biochemistry of viruses, that will minimize the side effects of the medicines. They should also be of particle size smaller than viruses to enable them to reach all infected cells to stop the mystery called sanctuary cells. Features we suggest for antivirals, anybody who is attempting to develop antiviral medicines should target features, mechanisms that will not affect the normal cells. Electrostatic attraction by which electrically charged particles absorb onto particles of opposite charges is a physical effect. Healthy cells are neutral, they don't have charges, while abnormal cells and viruses are electrically charged. You can see the references. It is already literature that abnormal cells have negative charges, while viruses are either positively charged for the RNAs or negatively charged for the DNAs. So we can use this as biomedical marker to design medicines that will target those charges. Those medicines will not have severe side effects because normal cells do not have electrical charges. Molecules of a medicine called aluminium hypomagnetic, which is already approved by World Health Organization as a medicine and as a pharmaceutical agent, are made of nanoparticles that only 0.96 nanometers thick. You can see the reference number 3, reference number 4 are referring to that medicine. It's already a medicine that exists. The molecules are made of smaller particles that only 0.96, that is less than 1, and they have electrical charges. That means they are smaller than any known virus. HIV is 110 nanometers. COVID-19 is that is smallest HIV 110 nanometers. Smallest COVID-19 virus is 60 nanometers. So there's nowhere HIV can reach that, or COVID-19 virus can reach that this medicine that is less than 1 nanometer cannot reach. The nanoparticles have both negative charge and positive charge end. I didn't discover this. I'm quoting literature. We are starting from literature from the known to unknown. The reference number 4 says that this particular medicine that have been in use for a long time has a both positive charge and a negative charge, and viruses have charges. We are now advocating opposite charges to electron attraction. Present pharmaceutical use of AMS include to aid disintegration of capsules when swallowed, because if capsules are swallowed and they don't burst, they will not treat the patient. So they are added to capsules to enable them burst when they in the stomach, to enable them release the medicine they have. So they will also be able to investigate abnormal cells if they absorb to abnormal cells. Therefore, hidden HIV or COVID-19 virus and any other virus inside such cells will be unmasked, and if they are unmasked, they will be mopped out. So we are introducing to the medical sciences opposite charges electrical attraction as a mechanism for treating viral and abnormal cell diseases, including cancers, HIV/AIDS, and COVID-19. Since AMOS is a silicate, it will enhance immunity because silicates are immune stimulants. As a stabilizing agent, it will also improve efficacy of antimicrobials. You can see the references referring to those things, but they already facts that are known in literature. Enhancing immunity and improving efficacy of antimicrobials will lead to effective treatment of secondary infections, which will also aid recovery from viral disease. These are facts already know that when you manage secondary infections, patients usually recover from viral diseases. So apart from mopping out the virus, it will also be able to enhance immunity of the patients, and it will also be able to enhance the efficacy of antimicrobials, leading to effective treatment of secondary infections, which will also add to recovery from viral diseases. Nigeria, where we work, does not have natural depots of aluminum silicate. You can see the chemical formula of aluminum silicate, but there are large deposits of aluminum silicate and aluminum silicate. You can also see their own chemical formula. So from this formula, we now knew that we could get what we are looking from what we have. So we were able to react 1 volume of aluminum silicate with 3 volumes of manganese silicate to get 2 volumes of aluminum manganese silicate, which Nigerian government has patented as antivat. Also, because aluminum silicate is not absorbable, before now, it's not being used to treat systemic disease. It's used to treat gastroenteritis and ulcers, passing through the mouth, the stomach, intestine out. It doesn't get into blood. So, but there's a literature that says that you can use simple sugars to carry electrical charge molecules across mucous membrane by the principle of active transportation. So we are using glucose monohydrate, glucose, to transport the nanoparticles because the electrical charge across mucous membrane into blood. Blood now circulates to all parts of the body so that they mop the abnormal cells and viruses wherever they are, thereby closing the chapter of so-called sanctuary cells. With the antivirus, the ultrananoparticles particles cross physiological barriers to reach all infected, including so-called sanctuary cells. Since the antivirus acts physically against features, that is electrical charges, which are specific to viruses and the abnormal cells, it does not cause intolerable side effects. The medicine is safe for long treatment required to treat to cure even HIV/AIDS. It also leads to effective treatment of second infection, we have said it before, and so aids clinical recovery from viral and abnormal cell diseases. The antiviral synergy. Destroy infected cells, mopping viruses, normalizing immunity, terminating secondary infections will all lead to cure for viral diseases, including HIV/AIDS and COVID-19. Reason existing antiretroviral medicines do not cure HIV/AIDS is either that their molecules cannot reach the sanctuary cells or their side effects are intolerable, so that patients do not continue treatment, they have to discontinue. Nigerian government has patented the medicinal synthetic aluminum silicate as a broad spectrum antiviral medicine and antiretroviral medicine. I'm trying to emphasize that this is what it was registered for in 2017, broad spectrum antiviral medicine. That is to say that any virus, because every virus has a charge, either negative or positive. Since our medicine has both positive and negative, it doesn't matter which charge a virus has. There's an opposite charge on the medicine. That opposite charge will bind to the virus and mop it out. So we have patented this even before now. Trial of the antivirus on HIV. We have done a lot of publications on it, but we chose to We chose a particular trial because that was government verification of our claims. The Nigerian Institute of Medical Research, which is a government agency, certified the antivirus safe by toxicological tests on mice. There was no need for it because it's an old medicine, but they decided to check again. But thank God they checked and confirmed that it is safe. Then 3 HIV/AIDS volunteers were treated as first-phase antiretroviral trial of the medicine. The medicinal synthetic amino and ampicillin formulation, which we call antivirus A, was produced, and also we produced antivirus B, which is the amino acid alone. We had to make the 2 formulations because in HIV, there are secondary infections. We need to clear those secondary infections, but you don't give antivirus for too long. To avoid giving antivirus for too long, we now made it to do the first one, which is taken for first 30 days. We call it antivirus A. The second one does not contain antibiotics, so that even if it means 1 year, 2 years, because some patients have lasted for 2 years before they can cure HIV, so they can go on without having a serious side effect. The NIMA placed the patients on antivirus A for 30 days. Thereafter, they changed to antivirus B and continued. We have to continue until the patient becomes HIV negative, both antigen and antibody. Because it's a binder, okay, first of all, each patient was also treated with immunosuppressor protection. Immunosuppressor protection contains so many things, but what we are interested in are the antioxidants, because HIV destroys infected cells within the body, and the medicine will help to destroy infected cells because they are also abnormal cells which are electrically charged. Because these cells are being destroyed, free radicals are being released, we can damage organs. So there's need for this immunosuppressor protection to absorb those free radicals to protect the organs so that the patient can continue with the treatment. So because of that, the patients are asked to take the medicine at night because it's a binder. Because if he mixes with food, you go to bind to food, and if you bind to food, you won't be able to do his work. So the patients are advised to take the medicine at night, 2 hours after meal, because 2 hours after meal, we imagine the stomach is empty, while the immunosuppressor protection is taken in the morning in full stomach. If the patients have to take any other medicine, they are also advised to take those medicines either 2 hours before the antivirus or 2 hours after to prevent binding to food, because if you bind to food or to drug, you won't be able to do his work. Viral loads of the patients we are used to monitor, to assess the effectiveness of the treatment, and also we ask the doctors to assess their clinical recovery every month. Results: HIV load of the antivirus treated patients, instead of reducing, had 41.03% increase, that is above the baseline in the first month, before it started reducing to 22.62%, it still increased, which is to say in the second month it was still above the baseline. Now that's not surprising, because like we suggested that because of the negative charges which infected cells have that go to destroy infected cells, that suggests that infected cells have been destroyed to unmask the infection, so that those viruses that were not detected earlier were now detected in the first month and second month, before it started now going down. By the third month, it now went below the baseline to 54.18%. Fourth month rather, 55.27%, and by the fifth month, it has gone down to 76.69%. The calculated viral load reduction rates are as on table 1, while the results that from the agency that tested verified our claim are on table 2. You can see table 1, that's table 2. From here, we did the calculation which gave us table 1. Conclusions: initial increase in HIV load of the patients suggests that the antivirus destroyed infected cells and unmasked hidden HIV infections before mopping them out. The NIMA research, like I said earlier, was to verify our earlier reports. You can see references from 11 to 16. We have been publishing extensively on the effect of this medicine on different viruses. We have tested so far 6 RNA viruses and 3 DNA viruses, including HIV/AIDS. And we have reported cure of HIV/AIDS almost every month. We get one cure, or that when we mean cure, we talk about people becoming HIV negative, both antigen and antibody. According to World Health Organization, the 76.69% reduction in HIV load of antibiotic patients suggests that their immunity must have normalized. That is to say, at least CD4 of 500 and above. Normalizing immunity and the continuous mopping of infections are adverse mechanisms for curing viral diseases, both RNA and DNA. The continuous mopping the virus and also normalized immunity. Synergy between immunity now and medicine leads to cure of even HIV/AIDS. Recoveries from HIV/AIDS earlier reported and the 76.69% infection reduction reported by NIMA are due to electrostatic attraction, mopping of HIV that's oppositely charged by negative charges on antivirus nanoparticles. The nanoparticles use their negative charges to bind to positive charges on HIV, and that is why we were able to achieve 76.69% in this particular clinical trials. Other clinical trials we have already achieved the 100% mopping out. So the medicine will also mop COVID-19 virus because COVID-19 is also an RNA virus and also has a positive charges. Any medicine that reduces 76.69% of HIV infection in 5 months, despite the severe immune deficiency, will terminate COVID-19 virus infection, which has no immune deficiency, in few days. That is already known because, like I said earlier, millions are being cured of COVID-19 every day, whereas WHO records that only 2 persons have so far recovered from HIV in more than 30 years, but we are correcting them because here in Nigeria, by God's grace, almost every month, at least 1 person recovers from HIV. When they update their record, you see that we have been achieving cure in Nigeria. The medicine will cure COVID-19 patients. We therefore call on World Health Organization to conduct clinical trials of the antivirus on COVID-19 patients to confirm its efficacy. Just like a chloroquine is being tried and vaccines are being tried, since this is an old medicine, already patented, already confirmed, approved medicine that is in existence, there's no harm in trying it. And the mechanism we have discussed is very, very clear. Opposite charges electric attraction. It's already a literature that this medicine has negative charge and positive charge. It's also a literature that the virus we're talking about has positive charges. So there's no reason why this thing will not cure it. So we are suggesting that World Health Organization should quickly conduct clinical trials, just like they're doing on chloroquine, with this medicine, and by God's grace, the efficacy will be established. When the efficacy is established, we suggest that every country should adopt testing of all citizens so that positive persons should be isolated and treated. With that, with this strategy, COVID-19 could be eliminated within countries in the next 1 year and eradicated in the world in the next 2 years. Thank you very much. You can see the references like I said earlier. If you go through all this, you find out that it is true that this is an old medicine. It is also true that this medicine has positive charge and negative charge, and that every virus is electrically charged. And if all this is true, there's no reason to say that it will not be able to cure COVID-19. Thank you once more.
Any questions to Dr. Moduzuki Ezubi? So I have small questions from you. Why is COVID-19 spreading so fast? Why is COVID-19 spreading so fast?
Please repeat. I didn't hear you.
Why is COVID-19 spreading so fast?
Are you?
Why is COVID-19 spreading so fast?
I was so fast?
Yes, yes. No. My question is.
Okay. Do you want me to repeat? What do you want me to repeat?
Why is COVID-19 spreading so fast?
Why is it spreading so fast?
Yes.
Okay. COVID-19, maybe I think because of its method of transmission, because it's transmitted by not air, so it's droplet. droplet inhalation. Whereas the HIV, for instance, which are comparing that, HIV is sexually transmitted, so one can easily dodge it. HIV. It's not that easy to avoid COVID because once you associate with human beings and are breathing or coughing, that droplet inhalation can lead to infection. I think that is the problem. So the problem of COVID-19 is spread so fast, but HIV does not spread that fast. But HIV is more stubborn if you're trying to cure it. So COVID-19 spreads fast is a problem. But if a treatment is easier because it doesn't trigger immune deficiency.
Yes, thank you. Thank you very much, sir. Any questions to Dr. Mazubi? Any questions to Dr. Azubi? Okay, thank you very much, sir, for giving me a valuable presentation. On behalf of OCMs of Infectious Disease Congress 2020, I want to thank you for insight presentation. So next we invite Dr. Kharobi to give poster topic of Dr. Sonia Dhaobi from National Observatory of New and Emerging Disease, Pasteur Institute of Tanzania, Tanzania. Sir, just you can remove your
I will meet myself. I meet. This one.
just enlarge the pair. Just.
Hello.
Yes, yes.
We're finished by the third poster about influenza vaccine in Tunisia, entitled Determinants of Influenza Vaccine Uptake in Tunisian Pregnant Women. In spite of increasing evidence of flu vaccine effective protection and safety for pregnant women and for her fetus, flu vaccination is far from being a common practice among Tunisian pregnant women, and the associated factors are not determined. The aim of our study was to investigate factors associated with influenza vaccine status in pregnancy. So we carried out a cross-sectional study in Tunisian primary and secondary healthcare facilities over a period of 3 months from March to May 2019. All consenting pregnant women aged 18 years old and or above who had attended a routine antenatal care visit at the participating care centers were included. Data were collected through a questionnaire administered by interviewers previously trained. So the determinants of vaccination uptake were identified using logistic regression analysis. Of the 1,157 women included in the study, only 4.4% reported that they had been vaccinated against influenza during their pregnancy. The two principal factors and the alone factors significantly associated with the greater vaccination uptake were presence of comorbidity prior to the pregnancy with an adjusted odds ratio equal to 3.6 and the mother's perception that flu vaccination of pregnant women helps to protect the newborn against influenza with an adjusted odds ratio of equal to 2.3. So ensuring, as a conclusion, ensuring an education program about the risk of flu and the safety and efficacy of vaccination into routine antenatal care is primordial to improve flu vaccination coverage among expectant mothers. Thank you.
Hello. So, any questions to Dr. So, thank you very much, Doctor, for presenting on behalf of Dr. Sonia Dhaobi. So, now we welcome Dr. Saifan Malik from Pakistan to join the event. Saifan Malik. So Dr. Saifan Malik, you can join the event and you start your presentation. Hello. Yeah, Dr. Saifan Malik. Dear participants, we have 2 to 3 more talks. So meanwhile, just we'll take 4 to 5 minutes break and we'll rejoin again. As 2 to 3 speakers they are unable to upload their PPT, we ask you to rejoin after 4 to 5 minutes. Let us take 5 minutes break. Hello. Yes, sir. We will start the program again. Dr. Saifan Malik. Hello. Hello, Mr. Saifan Malik. You can start your presentation. Hey. Hello. Yeah, Mr. Saifan, We ask you again to start your presentation. We have uploaded your PPT from our side. Saifa Malik is not in this meeting.
Saifa Malik, please start the program.
Hello, Dr. Saif Malik, we ask you again. Okay, no problem. So, the last presenter will be Dr. Manisha Mandal from MGM Medical College from India. Dr. Manisha Mandal, we ask you to join the event with your presentation. Hello.
Am I audible?
Yes. Hello. Yes, madam. Just you can start your.
Am I audible now?
Yes. Just reduce the volume. Just reduce the volume. Hello. Yes, madam. You can continue your talk.
Okay. Let me share my screen.
Yes.
হ্যালো, হ্যাঁ বলেন।
হ্যালো,
হ্যাঁ ওই ফোন হয়ে গেছিল একটু।
yeah madam, just
হ্যাঁ হ্যাঁ হ্যাঁ
मेरा दोस्त का फोन आती लो
সাহেবকে না না আমি ওই অনলাইনে পড়াচ্ছি।
Yeah, Dr. Safi Malik, we ask you again to start your presentation. Hello. We ask you, Dr. Saif Malik, as well as Dr. Manisha, to join the event. We are wasting a lot of time from because of you. Dr. Manisha Jain, we ask you.
Yes. Can you hear me now?
Yes, yes. Please put your volume.
But my browser is preventing access to share my screen.
Please reduce your volume.
Okay.
Please upload your PPT, madam. So we are going to close the event. Last talk will be yours.
Can you hear me now, sir?
Yes.
But my browser is preventing access to share my screen.
Yes. madam, if you are facing a problem, please send us the PPT. We can play behalf of you.
Okay, then I'm sending my PowerPoint. Okay, Okay, I'm sending.
Starting and also we are requesting you number of times instead of wasting time. We ask you number of times to just.
Okay, I'm sending.
Please reduce the volume. Hello. Hello. Yeah, Saifan Malik, sorry. Hello. 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 Yeah, doctor. Hi, among two participants, Dr. Manisha Mandel as well as Safian Malik. Yeah, we are waiting for your talk. Please upload your PPT and start your presentation. We did more than 40 minutes.
Hello.
Hello.
Hello. Can you hear me?
Yes, sir. Please go ahead. Shall we upload your PPT?
Okay. Okay.
So, may I know your good names?
Yeah.
Hello. May I know your good name? Am I speaking to Dr. Malik? Hello.
Hello. Here is Fan Malik.
Yes, just be online, sir.
Okay. Let's start my PPT presentation. Please share my presentation.
Yes. So, start, sir.
Okay. So here is
Just
Fan Malik.
increase your volume, sir. We are unable to hear your voice.
Okay. Now you hear me?
Yes.
Okay. So my name is Fan Malik, and I am a microbiologist, and my topic of presentation is HIV vaccine.
Mm-hmm.
And as you know, HIV stands for the human immunodeficiency virus, and it is the causative agent of AIDS. So, AIDS is a disease in which a person's immune system allows life-threatening opportunistic infections and cancers thrive. Next, so as you know, the mode of transmission of HIV is mainly sexually contact, blood transfusion, syringes or needles, and also from mother to fetus during pregnancy, and also by breast milk if she is HIV positive. Without treatment, average survival time after infection with HIV is estimated to be 9 to 11 years. Some people's immune system can naturally control the virus for years or decades. Next. So now we talk about the HIV prevalence. So it is estimated that 36.7 million people worldwide infected with HIV. It's a huge amount. In Pakistan, there are almost uh, 1 lakh 30,000 people are living with HIV, and 5,500 deaths occur annually due to AIDS. The number of cases is growing in Pakistan due to certain reasons. Recently, there was an outbreak of HIV in Larkana, Pakistan. As many as 4, 445 people, including 356 children and 89 other adults, have so far been tested HIV positive. Next, expert. So transmission in Pakistan. So in Pakistan, the main reason of AIDS pandemic in Pakistan, but some prominent ways of transmission are listed below. So these are the syringes, unsafe medical practices, like the doctors don't change their syringes, and drug users, gays, non-marital sex, uh, repatriated migrant workers. Next. To control AIDS, different drugs and preventive measures such as vaccines are used. So, what is vaccine? Vaccine is a substance that teaches the body's immune system to recognize and protect against a disease caused by an infective agent such as virus. Next, HIV vaccine. The vaccine being tested do not contain live HIV, killed HIV, weakened HIV, or HIV infected cells. Instead, scientists use individual genes or proteins that trick the body in order to stimulate an immune response. No, no vaccine has been proven effective enough for widespread use, but scientists are working on a number of approaches. Next, hello.
Yes, sir. You can go.
Okay. Okay. Why do we need HIV vaccine? Because no major viral epidemic has been defeated without vaccine. So vaccine is necessary to control the viral disease because treatment is not possible of viral because they change their genetics. So we need vaccine. Vaccines have significantly reduced the number of illness and deaths. Even a partial effective AIDS vaccine can save millions of lives. Vaccinating large number of people would require relatively little equipment and expertise. But unfortunately, no effective HIV vaccine is available. But back please. Developing an HIV vaccine is difficult because numerous modes of transmission. HIV kills the immune cells of the body used to defend against disease. HIV makes many copies of itself and mutates. Mutations leads to the different subtypes of virus throughout the world. Nobody has ever eliminated HIV with their own immune system. Next, two types of vaccine: therapeutic vaccine and preventive vaccine. Next, therapeutic vaccine designed for people who are living with HIV, like for patients. If effective, would train the body's immune system to help control the HIV in the body. Preventive vaccines designed for people who are not infected with HIV. If effective, would reduce the risk of infection, may reduce viral load set point after infection. How HIV vaccine work? Vaccine would carry a component that looks and feels like HIV, but is not HIV and cannot cause HIV infection. Vaccine components are copied pieces of the virus known to generate an immune system. Upon exposure to HIV, antibodies and killer cells would be waiting to prevent and for control infection. Humoral immunity. So primary action of humoral arms is creating antibodies, Y-shaped proteins produced by B cells in response to a pathogen to prevent infection. Antibodies have multiple functions, attaching to and helping destroy pathogens, keeping the pathogens from entering host cells, neutralization, which is called neutralization, and calling other cells into action, sensitization. And next, cellular immunity. Two types of T cells, cytotoxic T lymphocytes and T helper cells. T cells recognize HIV infected cells, coordinate the immune response, helper cell, and kill the infected cells. Next, how is the vaccine development? So here is the process of vaccine development. First one, discovery and discover the antigen that, and then vaccine design, and then preclinical research on different animals, lab animals or volunteers, and then clinical trials. Production of an HIV vaccine. Next, collection of strains. Strains of HIV are actively mutating virus are collected from the blood of elite neutralizer. These are patients naturally make antibodies that neutralize formation of virus family tree. Scientists create a family tree of the viruses based on the DNA sequences of one protein GP120. Researchers then test if elite neutralizer antibodies now to stop many HIV strains by grabbing onto their Go 120 proteins are able to recognize these GP120 variants. If they are the common ancestors is determined by computational method. Next, insertion of fragment in plasmid. Using the DNA sequences from the fragments of GP120 protein recognized by the antibodies, then they synthesize the fragment and insert it into a circular piece of DNA called a plasmid. They add the plasmid to a mammalian cell culture. Next, incorporation of fragment in mammalian genome. Inside the cell culture, the mammalian cells incorporate the ancestral GP120 DNA fragment into their own genome. Formation of fragment copies. Like a factory, each mammalian cell reacts the DNA instructions to make copies of GP120 fragments topped with branching sugars. Testing. So after the formation of vaccine, these fragments are then tested to check if the broadly neutralizing antibodies used to screen GP120 vaccine formation. If the antibodies do bind, then the GP120 fragments are synthesized in large amounts and purified. Then it is used to prepare vaccine. Production of an HIV vaccine. So these are the steps of HIV vaccine. So before we prepare the strain, and then we prepare the vaccine, and then clinical trials, and then uh, uh, launching in market. Next, efficacy of different vaccines available. Next, these are the different vaccines available for AIDS, HIV in. So these vaccine is AIDS, Cevax, Thailand, no effect. So these are the step MRKAD5B, Australia, Brazil, Canada, Dominican, Jamaica, US. So this vaccine immunization halted earlier for fertility. And then in 2007, from Billy MRKAD5B, South Africa, and then immunizations halted based on step trial results. In 2009, Thai Prime boosts RV144 produced in Thailand, and modest efficacy 31.2%. And then in 2013, HVTN 505 DNN85 produced in US. Immunization halted early for fertility. Vaccine regimen did not prevent HIV infection nor reduce viral load among vaccine recipients who became infected with HIV. Next, World AIDS Day, designated on 1 December every year since 1988, is an international day dedicated to raising awareness of the AIDS pandemic caused by the spread of HIV infection and mourning those who have died of the disease. It is to aware the people about HIV, its causes, treatment, and preventive measures available to eliminate it from the world. Next. Thank you for listening.
Yes, thank you. Thank you very much, Dr. Saiful Malik. Any questions? Any questions, Dr.?
Yes, sir. I have some inquiry.
Yes, yes, sir.
First inquiry, the vaccine do not contain kill parasite or virus that contain a protein that increases the immune response. So it is a vaccine or a immunobooster. First question. Then second question, it is a if it increases the immune response, it is will be applicable to an affected person.
Your question is if vaccine produce humoral immunity, then
These vaccines produce a protein. It is not a pathogen, do not contain pathogen. So it is a vaccine or it is a immunobooster because the protein increases that the protein increases the immune response.
okay.
The
So
vaccine contain protein.
okay, a vaccine is divided into different boosters. So it's a duration. You can say we need immune boosters because if one we injected the vaccine, maybe after some years or some time of period, the pathogen again active. So then we need immune boosters, and the that also contain a deadly pathogen that cannot cause HIV, but it's teach the immune system to prevent the from disease.
Second inquiry is that this it is increases the immune response. So why it is not applicable to a infected person?
It cause immune response. And then I cannot understand
So
your question.
then it is why it is not equally protected against in case of infected person.
In infected person, in infected person, uh, because he is infected from HIV. So recently there is no working on treatment of HIV, but we have not find the treatment of HIV. So in patient, we cannot use vaccine as a immune. Vaccine is the product that we use before the disease, so that we cannot develop into disease.
Yes, that the viruses decreases the immune response and the vaccine increases the immune response. The decreases and increases if they equal, the patient will be survive better. Yes, is not it?
Hello.
Yes, Dr. Malik.
Hello.
Hello,
Yes.
Dr. Sumundra.
Yes, sir.
So you can ask the question again, sir. It's not able. It's not getting proper. What the question you are asking?
Yes, sir. The vaccine increases the immune response and the viruses decreases the immune response. They are destroy the immune system. So if they are equally affected in a patient, then the survivability rate will be increases in case of patient.
Yes. Uh, so virus is active. So when it enter into the body, virus can do not activate the immune response. Virus cause the immune response and weakens the immune response of body. Virus weakens the immune response of body, and when immune system of body weak, then we can get multiple disease, multiple opportunity infection. But vaccine is a deadly virus. it cannot only antigenic parts of the virus is active, and the pathogenic parts of virus is dead in vaccine. So when we inject vaccine, it stimulates the immune system to cope with the original virus. If original virus comes, then the body have antibodies that can beat the virus. So there is a difference between virus and vaccine. Virus is active pathogenic, and the vaccine is non-pathogenic. Its the pathogenic determinants are dead. Only antigenic determinants are active. Do you get it, Dr. Smundra?
Yes. 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 Yes.
Okay.
Yes. 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 Yes.
Thank you, sir. Any question else?
Any questions to Dr. Saifan Malik? I think Mr. Saifan Malik.
Can you hear me now? Hello?
Yes, madam. Just you can go. You can go with the presentation.
Can I proceed?
Yes.
Can I proceed? Okay. Honorable Chairpersons, organizers of online conference on infectious diseases 2020, I am Dr. Manisha Mandal, Assistant Professor from the Department of Physiology, MGM Medical College, Kishanganj, Bihar, India. At the outset, I would like to express my gratitude for giving me the opportunity to present my paper entitled, previous slide please, the first slide please. The title of my paper is, first slide please, detecting, no, the first slide, beginning, yes. Actually, I work in Linux environment. Somehow it has got changed. It has got altered. Okay, I'm continuing with this. Okay. Yeah. So the title of my paper is Detecting Change Points During COVID-19 in India. Assessment of Key Epidemiological Parameters and Intervention Tracking. The COVID-19 pandemic in India is part of the worldwide pandemic of coronavirus disease 2019 caused by SARS-CoV-2 virus. The first case of COVID-19 in India, which originated from China, was reported on 30 January 2020. Since then, 8 months have elapsed and the COVID-19 outbreak has spread entire India. Currently, India has second highest number of about, next slide please. Next slide, sir. Yes. Currently, India has about second highest number of 98 lakhs confirmed cases in the world, with about 54 lakhs of active cases and more than 86,000 deaths as of September 19, 2020. Now, in an attempt, please stay on the third slide, sir. Previous slide, please. Yes, please continue staying there. So, in an attempt to minimize the growth in number of COVID-19 infections in India, non-pharmaceutical interventions have been applied for separating the infectious population from the susceptible population. These initiatives aim to strategically reduce the increase in infectious to a level where the healthcare systems stand a chance of minimizing the number of fatalities. In this regard, some of the critical indicators for policymaker response planning include predictions of the infected population, estimates of healthcare service demand, and whether current containment measures are effective. In addition, exploring the epidemiological features of COVID-19 in India will help to understand the nature of the disease in context to the Indian scenario. Modeling plays a significant role in understanding the basic epidemiology of an infectious disease and in evaluating the effectiveness of implementing control strategies. The current study stands for the exploration of the epidemic condition of COVID-19 in India, utilizing more recent data available up to September 17. Thus, this study estimates COVID-19 spread in India by assessment of key epidemiological parameters. The lower part of the slide is not visible here. Okay, I'm continuing anyhow. So, it is involved the aim of the studies, the assessment of key epidemiological parameters such as reproduction number R of an infectious disease defined as the number of infectees generating from one infector, where infectee refers to a patient getting infected by an infector who is a primary COVID-19 case patient. In other words, R is the average number of secondary infections produced by an infected individual and otherwise susceptible host population, and is given by the ratio of disease spreading rate to the recovery rate. Previous slide, please. Previous slide, yes. Please stay in that slide. Okay. Next is the estimation of serial interval defined as the time period between the onset of symptoms in the infected and onset of symptoms in the infectee. The serial interval may be seen as the generation time or renewal time of the infected population, considering the onset of symptoms to be seen as the onset of infectiousness. The third parameter is the daily growth rate. It is not visible in this slide anyhow. So daily growth rate of COVID-19 is the ratio of daily new growth and total cases on the last day, whereas case fatality rate, it is obtained from the ratio of total deaths and total cases on a particular day, and similarly case recovery rate, it is the ratio of total recoveries and total cases on a particular day. So the two other aims of the study is to assess the changes in these epidemiological parameters and if there is any alteration with application of the intervention, as well as to make some short-term and long-term forecast scenario of COVID-19 situation in India. Next slide, please. Next slide, yes. So, in order to achieve this aim, the study was broadly divided into two parts. First is the epidemiological modeling. Second is the estimation of epidemiological parameters using Bayesian inference combined with MCMC sampling. Next slide, please. Yes. The data on ongoing COVID-19 pandemic in India were retrieved from COVID-19India.org and Johns Hopkins University Center for Systems Science and Engineering dashboard. The codes for this research article pertaining to COVID-19 situation in India was run on Jupyter Notebook using Python 3.8 version, and the code was based on GitHub repository by the Pressman group, published by Daily Nature Science 2020. Next slide, please. So the epidemiological modeling on which this study is based is comprised of units. First, it is the SIR model, that is susceptible, infectious, and recovered model. In this model, this is based on the concept that a time varying basis of this model is that the cumulative number of COVID-19 cases per day it is asserted on the basis of the total number of population size. This being divided into three mutually exclusive infection states. Assuming that any infectious person denoted by I has a probability of contacting any susceptible person denoted by S and later recovered denoted as R, so that N is equal to S plus I plus R. The dynamics of the pandemic in India was modeled using the following three differential equations as shown in the next slide, please. Yes, this shows the time variation of susceptible, infectious and recovered population given by the terms on the right side, where lambda represents transmission or the spreading or the infection rate for infected people to infect susceptible people, and mu is the recovery rate for infected people to recover. Next slide, please. Another model known as the SCIMR model, the robustness of this model was also applied partly in the study. This model actually assumes an added exposed period denoted as E due to the reported incubation period of COVID-19 during which individuals are not yet infectious. The SCIR models the transmission of individuals between 4 stages of condition: being susceptible to the condition, being infected and in incubation, having the condition and being infectious to others, and having recovered and built immunity for the disease, so that N is equal to S plus E plus I plus R. The model is again based on following 4 differential equations as shown in the next slide, please. Yes, again here the time varying relationship of susceptible, exposed, infected and recovered population given by the terms on the right side is shown here, where sigma is the rate at which individuals in incubation become infectious, and 1 by sigma represents incubation period and 1 by mu represents contagious period. Next slide, please. Now, extensions to the SIR and SCIR models have been used here. Now, an extended version of these 2 models have been used so that it incorporates some of the observed phenomena related to COVID-19. Firstly, a delay factor has been included. So, this delay factor, it is the time duration in becoming infected and being reported in the confirmed case statistics, such that the confirmed reported case denoted by CRT here at any time is given by the equation as shown here. It is further assumed that the spreading rate lambda is time varying. It is not a constant factor. Now, some weekly modulation factor has also been applied here, which this also changes the confirmed reported cases being dependent on some factors like weekly modulation amplitude and weekly modulation phase as given by the equation here. Next slide, please. Now, Bayesian inference with Markov chain Monte Carlo sampling has been applied here in COVID-19 data, which is based on the Bayes theorem, according to which the posterior distribution of vector of model parameters W given the model M and observed data is given by the expression on the right side, where the first term represents the data likelihood and PD is the evidence. The Bayesian framework, it allows for the posterior inference of parameters which updates prior beliefs based on data driven likelihood. The other consideration here that I mentioned here, which is PW, this the likelihood, it indicates the probability of observing the reported case data given the assumed model. In this study, student T distribution was adopted as the likelihood that minimizes discrepancies between the predicted and observed reported cases. The prior settings for the model parameters are listed in the following slides. Next slide, please. Now, Monte Carlo, Markov chain Monte Carlo sampling, this was used to sample prior from the posterior distribution of the parameters. This method approximates solution to complex numerical problems by simulating a random process. A Markov chain is a sequence of random variables. WT select. Previous slide, please, sir. Previous slide. Yes. This Markov chain Monte Carlo, this is a sequence of random variables expressed by the equation given here. Hereby, the Python package PYMC3 with no U-turn sampling has been used with multiple Markov chain to estimate the parameters. Next slide, please. Yes. Now, COVID-19 infection, it is a very great infectious disease. So, it is hereby assumed that the transmission rate of the disease is time varying with change points affected by government interventions and voluntary social distancing measures. Next slide, please. Yes, some of the interventions applied at different phases in India are listed here as per the characteristic of the intervention, number of interventions, characteristic and the dates of the interventions, such as people's curfew applied on 22nd March, lockdown applied in 4 phases beginning from 25th March to 31st May, followed by unlock phases in different ways, numbered as in law 1, 2, 3, 4. This was to ease economic with opening of some essential services, while some restrictions were not allowed in containment zones. So in this phase, different interventions have been applied. Next slide, please. Next slide, please. Now to the result section. This is the previous slide, please. Previous slide. Yes. The first part is related to the estimation of the epidemiological parameters of COVID-19 pandemic in India, involving the parameters such as R, that's reproduction number, serial interval, daily growth rate, case fatality rate, and case recovery rate. Next slide, please. Yes. The serial interval and the reproduction number of COVID-19 pandemic in India is shown here. The current value of R is 1, whereas the current value of the serial interval is it is about 36 days, not shown here in this. It is going to the lower part of the slide. So next slide, please. Next slide, please. Yes, this shows the previous. Yes, this shows the daily growth rate of COVID-19 pandemic in India, along with the variation of cumulative infected cases. The current number of cases is 8355742. The range is being shown here, and the current daily growth rate is about 0.92. Next slide, please. Yes, the case recovery rate and case fatality rate of COVID-19 pandemic in India, the ranges, the current values as well as the confidence interval is being shown here. The current case recovery rate is 43.34 and case fatality rate is 0.92. Next slide, please. The next part of the result, it is divided into 2 broad aspects for the assessment of any change in epidemiological parameters with times of applied intervention, and to make short-term and long-term forecast of future scenarios using SIR modeling mainly, using in both optimal and optional situation. Next slide, please. Yes, some of the packages that have been used with Python here include Pandas, NumPy, Matplotlib, SciPy, Pickle, PYMC3, and Theano Tensor, etc. Next slide, please. Next slide. Yes, considering the spreading rate in the very initial stage of the disease, here before the implementation of an intervention, the prior distribution settings for model parameters have been shown here for the spreading rate, recovery rate, reporting delay, initial infected population, and scale factor. So next slide, please. Yes, and now since we have said apart from the initial phase of the disease, when the disease progresses, the lambda is no more it is a fixed parameter. It changes with the application of interventions, and accordingly in the month of March and April, 3 scenarios were considered with the application of various social distancing measures, and for that the prior distribution settings for the model parameters using SIR is shown here as in this table. Next slide, please. Yes, now this slide shows the inference of central epidemiological parameters such as the infection rate, recovery rate, number of infections at beginning delay, scale factor, sigma, and effective growth rate of this COVID-19 situation in India in March in the very initial phases. So this shows that the posterior distribution for the parameters using SIR model for March obtained as median estimates where infection rate median value was equal to 0.13, the recovery rate was 0.12, reporting delay as 8.4 days, initial number of infections as 36 as shown in figure here D, E, F, G respectively, so that the basic reproduction number here is equal to lambda by mu amounts to 2.5. The SIR model exhibited good agreement with new cases in figure A and cumulative cases in figure B, both of which showed exponential growth. The observed data were clearly informative about the infection rate, lambda, initial number of infections I0, and scale factor sigma of likelihood as indicated by the difference between the priors shown by gray lines in the figure and posterior shown as histogram in figure D, F, and H. However, recovery rate, mu, and reporting delay were largely determined by the prior choice of parameters. Here, histograms match the gray line in figure E and G. This is to be expected for the initial phase of an epidemic outbreak, which is dominated by exponential growth. Here, figure I, this indicates the effective growth of active infection shown by lambda star in this figure, which is equal to the difference between the infection rate and the recovery rate before and after intervention. Now, lambda star, this quantifies the effect of possible interventions. As long as the number of infection and recoveries are small compared with the population size, the number of active infections can be approximated by an exponential growth with effective growth rate equal to lambda star equal to lambda minus mu. Thus, lambda and mu cannot be estimated independently. This was further supported by a systematic scan of the model's log likelihood in the lambda minus mu space, which showed an equipotential line for the maximum likelihood. So this suggests that the growth rate lambda star is the relevant free parameter with a median lambda star equal to 18% as shown in figure I. The control parameter of the dynamics in the exponential figure in the exponential phase is thus the effective growth rate. Next slide, please. Next slide, please. Yes. The effect of different possible interventions have been shown here in March for COVID-19 situation in India. Now, to simulate the effect of different possible interventions, the effect of interventions were modeled as change points in the spreading or the infection rate. Different hypothetical interventions after the initial phase were considered with respect to the magnitude or strength of the application of intervention, the timing and duration of intervention, and the effects on case number. Hypothetical interventions were based on the inferred parameters from the initial phase with median lambda 0 is equal to 0.3, median median recovery rate is equal to 0.12 from figure D and E of the previous slide, and were implemented as change points in the infection rate from the inferred initial infection rate to a new value. Here, initial infection rate denoted as lambda 0 and the new value as lambda 1. So, 3 different scenarios were considered for intervention starting on 16 March. Now, under no social distancing condition shown by green lines here, under this condition, infection rate or spreading rate or the transmission rate remains unchanged with the inferred rate lambda 1 equal to lambda 0 with median lambda 0 with median lambda 1 equal to 0.3, which is greater than the recovery rate, which is equal to 0.12. In this condition, it is assumed that public behavior remains unaltered. Under mild social distancing condition, here this is parallel to the application of intervention considered as mild social distancing, equivalent to the implementation of closure of all educational institutions. Under this condition, the infection rate taken to decrease by 50% with lambda 1 is equal to lambda 0 by 2. The median lambda 1 is equal to 0.15, which is still greater than the recovery rate being equal to 0.12. Now, under this condition, although people effectively reduce the number of contacts by a factor of 2, the total number of reported cases continue to grow, along with no social distancing condition for the time period of the reporting delay being. This is still an exponential increase of new infections after the infection becomes effective, because the growth rate remains positive, being equal to 0.03, which is still greater than 0. Under strong social distancing applied on 25th March, the infection rate assumed to decrease by 10%, that is lambda 1 equal to lambda 0 by 10, with median lambda 1 being equal to 0.03, which is less than the recovery rate. The assumption here are that the contacts are severely restricted, but some contacts still are unavoidable. No effect is visible even until the reporting delay is over. During this initial period, insignificant change in daily new infections occur within 2 weeks, equal to delay plus change point duration, and the total number of cases rise slightly. Even under this scenario, plateau is not achieved because effective growth rate, although negative, leads to an increasing number of new infections as seen later phases. Now, regarding the timing of intervention, yes. Okay. So apart from the strength of an intervention, its onset time has great effect on the total case number. For example, under strong distancing, the case number still rising. The effect of advancing or delaying the change point by just 5 days leads to decrease in cumulative cases. Now, this has only minor effect if the intervals of change are centered around the same date. This is related to the duration of intervention. In figure 2c, the adjustment of lambda 0 to lambda 1 for mild social distancing with durations of 14/7 and 1 day are depicted. The change point duration is a simple way to incorporate variability in individual behavior and is not linked to the reporting delay. A sudden change in the spreading rate can lead to a temporary decrease of new case numbers despite the fact that the effective growth rate remains positive at all times. Next slide, please. Yes. So this shows the inference of the epidemiological parameters in the month of April. Ultimately, the summarized values will be shown in later on. Next slide, please. Next slide, please. This is the effect of intervention on COVID-19 cases in April. And since initially the number of cases was very low, now with the cases rising, the effect of interventions are being shown here in this slide. Next, please. Yes, the hereby SIR model with delay have been applied using 3 scenarios in March and April. It shows that with 0 change point, the number of cases, it rises enormously, whereas with 1, 2 and 3 change point, the number of cases gradually it lowers down. Next slide, please. Next, please. Yes, this is a summary distribution of the infection rate with different change point application, and the daily new case number as well as the cumulative cases are being shown here. Next slide, please. Next, please. Yes, this again shows the variation of the changes in the infection rate with times of application of different social distancing measures and their effective growth rate. There is a gradual decrease in the infection rate with increase in the number of application of interventions, and along with there is also a decrease in the effective growth rate. Next slide, please. Next, please. Yes. Again here in the month of May, the different epidemiological parameters are shown here. Next, please. Next slide. Yes, the effect of intervention COVID-19 cases in May hereby shown here. Since long time has elapsed, the start of the total number of reported cases are not being visible here, but the daily new reported cases are the effect is being visible here. Next slide, please. Yes, this now unlock 1 phase was started from 1st June, and during this phase the various parameters have been shown here. Next slide, please. Yes, here considering the interventions that was applied in March, the effect on COVID-19 cases have been shown here. What it shows that with application of strong social distancing, the number of cases should decrease. Now next slide, please. Again here, considering the unlock 1 situation as well as its comparison with pre and post unlock phases. Next slide, please. Next, please. Yes, again this for the month of July. Next. Next. Yes, again similarly the effect of different social distancing measure as applied in March and later on. Next slide, please. Yes, comparison of the unlock 2 phase along with pre and post unlock periods. Next slide, please. Yes, this for the month of August. Next. Next. Yes, again in August, the effect of intervention in COVID-19 cases. Next, please. Next, please. Yes, the comparison of the unlock 3 phases with pre and post effect. Next, please. Yes, for the estimation of parameters beginning from 24th August to 7th September. Next, please. Next, please. Yes, again here the effect of interventions from in August to beginning September. Next, please. Next, please. Yes, here the SIR model was compared with SCIR model, and for that the prior distribution considered here for the time period March to April is being shown here. Next slide, please. yes, this is the effective growth rate, daily variation in the daily reported cases and total reported cases during this March to April. Next slide, please. Yes, some weekend modulation was applied and it was considered without weekend modulation and with weekend modulation. The SEIR model was used. Next slide, please. Next, please. Next, please. Yes. Previous slide, please. Yes, this shows the various estimates of ELPD-low and P-low. Although there is a comparable parameter values here, this shows that the application of weekend modulation does not affect here in this Indian situation. Next, please. Okay. Now, the previous slide is not being shown here, but what it can be said that in this study, the first change point is expected around 16 March as a result of the official recommendation, which related to closure of all academic institutions. The second change point, which is expected around 22nd March 2020, when mass nation curfew occurred for 1 day, and the third change point, which is expected around 25th March with implementation of lockdown 1, when all non-essential stores were closed and a contact ban was enacted. In this way, total 7 change points are expected here. Overall, what it can be said that whenever so long as the growth rate is larger than 0, that is lambda is greater than 0, then case number grows exponentially. If, however, the growth rate is smaller than 0, then recovery predominates, and in that case, new case decrease. The different dynamics, supercritical and subcritical respectively, are separated by the critical point when the growth rate becomes equal to the recovery rate. So here, what it was seen that there was a gradual decrease in the effective growth rate. There was a decrease in the reproduction number as well as the recovery rate. It also improved in the different phases of the disease from March to September. So here the short-term forecast of COVID-19 situation in India up to 1st October has been made, which estimates this estimates about 11 million, more than 11 million cases on 1st October. Next slide. Yes, here long-term forecast of COVID-19 pandemic in India has been applied using SIR model. It shows the variation of infectious cases, recovered cases, susceptible cases, and infectious cases using optimal and optional condition where the total number of infected cases on the last day has been taken as the population size, and in the optional condition, the population of India has been taken as the total population size, n equal to 140 into 10 to the power 7. So this shows that the COVID-19 pandemic, it is expected to end by 5th March 2021, involving more than 35 million infected cases with greater than 19 million deceased, about more than 3 lakhs deceased cases, and recovery exceeding 15.5 million cases. So this study, next slide please. Yes, this study highlights the temporal changes of COVID-19 transmission in India and the potential change point with the application of interventions along with short-term and long-term forecast scenarios. Thank you. That's all for the presentation. Okay, it's over now.
Yes. Any question?
I have a question, please, to doctor.
Yes, ma'am. You can continue.
Thank you, doctor, for your excellent presentation and excellent modeling. But I would like to ask you, what is the causes of market increase in India, the number of cases in India in such rate? And as you expect, it may reach 11 millions. And is there any intervention for decreasing or flattening of the curve? Thank you very much.
Hello. Yeah, Dr. Manisha, we have got a question from Dr. Professor Nahala Ibrahim.
Unmute me. Yes, can you hear me now?
Yes, madam.
Yes. So the situation in India is that so long as the infection rate and the recovery rate, this is very negligible compared to the total population size, and as long as the effective growth rate being equal to the infection rate minus the recovery rate, if it does not become less than 0, in that case flattening of curve will not occur. However, we can see that with the application of interventions, what has been found that there has been a gradual decrease in the key epidemiological parameters as seen by we have seen initially the reproductive number, it was about 2.5. With the application of interventions, what has happened, it has come down to 1, and when it becomes less than 1, then we are on the safe side. Moreover, there has been also gradual decrease in the infection rate and the recovery rate, as you can see from the data here. So this is the positive side of the application of interventions. Yeah. Because this is just because the infection rate and the recovery rate is negligible compared to the entire population, and this disease, it has been highly transmissible compared to the other diseases. So it is spreading very fast, but if the interventions had not been applied, the situation would have been far worse. So yes, this is answer.
Yes. Any questions to Dr. Manisha? Yes, that's all. That's all. Yes. So, any questions regarding this? Regarding this mentioned topic, so you can discuss, and just we will be closing the conference. Yes. So we take this opportunity and extend our sincere thanks to all presenters, especially Professor Nahala Ibrahim from Saudi Arabia, Dr. Shampada Mandal from India, Dr. Manisha Mandal from India, as well as Baskoda from USA, Izupile from Nigeria, as well as Dr. Gazin Karabi from Tanzania. We also wish to express our gratitude to session chairs and co-chairs for the minute-to-minute guidance and support for providing encouragement every part in the organization of this grant level. An event of this dimension cannot happen overnight. It requires meticulation, It requires meticulous planning, extension, and high for details. We thank everyone for involvement they have shown and willingness we are expressed to take the completion of tasks beyond the comfort zone. A special thank to Program Manager Ms. Lisa Han for her continuous effort in putting together one platform. Finally, we extend our appreciation for each of you of your participation in this conference. We hope you enjoy the conference and have your time spent here will contribute to your professional development and enable you to build a new collaboration in this important and rapid emerging field in the infectious disease 2020. Looking forward to meet you again in next time in physical event in 2020-21. So one more thing, we'll be sending officially the participation certificate officially to your mentioned mail IDs. If you have any queries or questions, you can keep through chat. We'll be sending to all the questions to participants. Thank you. Have a nice day. Good night.